Okay. I would think it would have stopped the session and restarted, but it didn't. That was very odd. That was very odd. Let's see if it tries it now. Yeah, there we go. All right. That looks a little bit better. When you guys get in, just let me know you're there, and then I'll start talking. This is a co-learning session, in case you're just wondering and you're just watching the beginning of the video. It's a co-learning session. It might take any number of paths. We could talk about anything here. There's really no rules here. If you don't like meandering, random conversations that are generally related to cloud native and Kubernetes, this might not be the place for you. But if it is, you just put it on, put it out over in the corner, and work on your cloud native and Kubernetes and coding and stuff. If you want to just kind of tune us in and have us on your sort of background while you're doing other things. This is 100% focused on what I want to learn, so I'll talk about that, and I'll answer questions as possible. But the point of this is for me to get certified as fast as possible, so that I can help other people get certified who want to, and I can just fill some gaps in my own learning. That's the goal of this video for the next 3 hours. If you take a look at the schedule, this is a couple changes here. There is just a couple logistical things. So if you go to the about, if you go to, let me show you. So if you go to Twitch, actually if you go to rbxrob.tv, it'll take you to Twitch. And from here, you can, if you can add on to the end of it, you can add /schedule. My stream is usually always on, so it's gonna be hard for you to find the schedule tab. That's the best way to get there. So /schedule, that'll give you the schedule. So this I don't particularly like how Twitch does schedules, but it doesn't matter because it's good enough. But if you would prefer a better schedule mechanism that you can like put on your phone and stuff and be notified of changes, which I'm going to be really good about when it comes to Kubernetes co-learning. I'll be adding boost stuff too, in case you're interested in the boost. The boost schedule stuff will be added as well. It's just not there right now. I want to find a good time for it. I want to leave it alone. We'll be adding boost AMA, and we'll be adding boost content development, which are two different things. And so, because I need to make sure those things happen as well. This entire morning I've been doing boost content development. So I think some people want to tune in for boost content development. I don't want to put it on the schedule unless I know it's going to happen. So it's not going to be like a regular recurring thing. The AMA will definitely be a regular recurring thing, but the other stuff I don't know. We'll have to take a look at that. I'm not ready to commit, but the cloud native Kubernetes learning I have to commit to. So I'm going to go ahead and put that there. All right. So what does that mean? That means that, so right now, if you want to go here, the other way to get to the schedule, which I had to drop it from my page. This is kind of sad, actually. There used to be a really great mechanism for, did you see this? Twitch categories? I know it's snarky, I don't care. I used to have a schedule in here. They use there's a Google tool for watching the schedule, and it stopped working. I can't control the extensions that break, and so I decided not to use it. I kind of want to put a link over here to the Google Calendar, but I don't know. Let me take a second to do that right now. That's an administrative thing I could probably do. So here's my Google Calendar. There's no secret here. No secrets I'm giving up, so nothing to worry about. Yeah, the Google Calendar, there's like lots of calendars. I hope we get to the right one. So no, cancel. I don't want to add that. That's some shit that I don't want to do. No, that's not the right one. I'm gonna go to calendar and go get it. I don't think there's any tokens in there. Even if there, it doesn't matter because I don't use this account for anything. Oh yeah, I did add it. This is the, what? That's not correct. Oh, this is me testing something. Yeah, this is me testing something. People don't even know we have a calendar on today. Yeah, that might be why. Who knows? What calendar is this? Sharing the settings. Here we go. Sharing the settings is on. And nothing secret here. So I can show you guys. Yeah. Change events. No. Integrated calendar. Public URL. Big long hairy ass URL. But whatever. Yeah, I wish they would figure this out. This is a good example of like bad engineering, if you ask me. So, how do I show Vim in Markdown? Or markup? That's a boost question. There's lots of places you can get an answer to that. I use a Vim plugin that I wrote, or extended, I should say. So this is the link to the calendar. I put that in Twitch. YouTube, I can't. Sorry, I see a lot of people on YouTube there. I cannot talk to you on YouTube because the chat on YouTube is busted. It's really getting abused. And so I had to take it off. Apologize for that. Link to the calendar, though. The quickest way to get to the schedule, let's just put it this way, is to go to twitch.tv/rdvxrob/schedule. And that I do promise to keep up to date. As well as a Google Calendar, which I, to this point, I'm trying to link. I think you get 5 of these, so I don't know if you can actually add an extra one here. I don't know if that's possible. I'm actually trying to figure that out right now, so I will do it off screen for a second while you come on in. If you're trying to figure, if you need something to do because you just joined, you can go read my About page, rdvxrob, on Twitch/about. You can go to the GitHub, github.com/rdvxrob if you want to read that if you're new. Otherwise, install VirtualBox and install Minikube. Okay, those are the 2 things that we did yesterday, and we're not going to do that today. So if you haven't done that, tough. You got to go back and you can watch, but I'm going to be doing stuff that you're going to be confused on. And right now I need to go change I'm going to change the customizations here for just a second. Let me see here, creator dashboard, settings. I'm sorry you can't see this, but we're going to the channel and we're going to set under brand, under about, bio has all the links, social links. I only get 5 social links. Oh well. Looks like I can't add a calendar social link. So I will do something else really quick. I should draw a picture of the calendar. You know what? I'll add it later. Let me get an image of the calendar. Images of calendar. 2021. Images of a calendar. And I get totally bored. No, those are all gross. I just want a basic image. No, fuck it. Okay, just go to this the schedule. Just click on schedule on Twitch. The end. And I'll add this later. Because I want to move on. I don't have time for that. You know, chopped up by a drug lord. I really was. I would love to explain that to you someday. So that was crazy. All right, don't get me on that. We've had a bunch of people leave already on Twitch. It's funny because I had like 33 people on Twitch and now it's dropped. It's coming back up, so we'll see. All right, we are doing an installation for Minikube. So I'm going to stand up, get my coffee, and then come right back. So this is like way less than 5 minutes. So I'm just going to put 5 here anyway. Okay, I'm back. Oh, we have espresso beans, chocolate espresso beans. You guys ever have those? They're really good. So I'm having I'm having decaf, but then I had a chocolate espresso bean. I think I'm addicted. I'm pretty sure I'm addicted. I don't care. You heard about this mud stuff? All right. So what are we gonna do today? So we're gonna I'm gonna set up. We're gonna start up a Pomo session. You guys know about that, right? To kind of do some time boxing here. We have until 3, and when 3 comes around, I know I'm kind of late, but that's okay. We're going to spend an hour and a half. I'm going to do another one of these tomorrow, by the way, from 12 to 3 as well. I need to do these pretty consistently for my own learning so that I can keep upskilling to the point where, I can do my job without question and, help other people do the same job. So my immediate goal today is to get Minikube with running with the VirtualBox engine and to install something in it. Now, I'm trying to decide, and this is what's fun. This is the fun interactive part of this whole thing. So I have a couple paths I can take in my learning journey here. I'm all about the choose your own learning adventure these days. That's the whole Boost content is being rewritten to use this sort of choose your own path kind of thing. And right now there's several different forks in the road that we're looking at. So I could go down the path of installing something in Minikube, like a plugin or something, like some operator that's needed, like Istio, which I need to do. I need to install Istio, if you know what that is. It's a microservice mesh that's used for service redirects and routing and all that stuff, which I need to do for sure because I want to the end goal for me is to recreate a single node cluster on my own laptop that as close as possible models my production environment, so that I can practice deployments like Jupyter Hub to it and still be able to get a reasonable test iteration going on that doesn't require access to our development cluster, which requires network access and VPN to be up and all that shit. I want to be able to create a run on my laptop sort of workstation lab that as closely as possible models my development and ultimately my production environment, so I can do my own staging. And I think this is kind of a critical part of becoming a Kubernetes application developer in general, because obviously you've got to write applications that use all of those pieces and everything and be able to iterate quickly and test every one of the little individual pieces. And Kubernetes can get really complicated really fast. So that's my end goal. Now, whether or not that is the next step on my path towards certification, I don't know, but that's a big piece of this. So the other path is just following one of their tutorials and to get something installed and running under Kubernetes. And they have got something that does that already. So there's kind of a tutorial path that they go through. And I think that's kind of where I'm leaning today, because I kind of want to stay on the path of the content that they provided, so that since that's the only content we're going to have available to us. So let's go ahead and open that up and make a decision. And then when we do, we'll start up a Pomo for the next task for the next 25 minutes. So going to Kubernetes Dot Io, and I actually have this open already. So I'm going to go get it. I must have shut it earlier. Yeah, I did. I mean, I had it all zoomed in and everything. So again, we decided to use the web browsers for this because it's the only thing you can use when you do the certification exam. So we want our resources to be consistent with what we would do on a test, which would be remote. You have to have your camera and all that stuff. We're not going to talk about the steps of certification yet. I'll definitely get to it. I've watched this video so many times. Let's see. Where's the getting started link? We lost it. Kakone, yes, I have. I don't remember much about it though, to tell you the truth. So, hello Minikube. try Kubernetes, follow the tutorials to learn how to deploy Kubernetes. Let's do this. Let's do all their tutorials because these are free and this is what's recommended. What is Kubernetes? Let's do these overview things, okay? Let's do these overview things really quick. I'm going to read them all, okay? So we're going to try to maintain our own idea of what things we've passed and stuff. I'm just going to read this stuff really fast. You can come back and read it slowly. I'm going to read it fast for my own purposes. What is Kubernetes? This page is an overview of Kubernetes. Kubernetes is a portable, extensible open source platform for managing containerized workloads and services that facilitates both declarative configuration and automation. That means you write what you want. Declarative means, give me this. I want a thing that does this, and it behaves this way. You describe behavior. You don't write the behavior. It is a large, rapidly growing ecosystem. Kubernetes services, support, and tools are widely available. The name Kubernetes originates from the Greek meaning helmsman or pilot, which is confusing because there's a tool called Helm. Kubernetes as an abbreviation results from counting the 8 letters between K and S. Google open sourced the Kubernetes project in 2014. That's interesting. I didn't know that. So K8 is the 8 letters in between there. Kubernetes. Kubernetes. This is what, by the way, the tag that I use in my Zettelkasten, and it's also the tag that's used on the internet. So if you want to find that, that's the one to use. Google open source Kubernetes project in 2014. Let me give you a little bit more backstory there. The project within Google was actually called Borg. They still have Borg at Google as of this moment, and they are actually. I read a blog recently. I don't have a link to it handy, but they're moving to Kubernetes internally, so they're even internally migrating off into their own open source offering. Kubernetes is no longer managed by Google, but heavily influenced by Google. It has its own cloud native foundation, which we talk about lots. Kubernetes combines over 15 years of Google experience running production workflows at scale with the best of breed ideas and practices. Going back in the timeline, here's a look at why it's so useful. Kubernetes is so useful. Once upon a time, we had hardware, operating system, app. And there's a diagram there that has a hardware at the bottom, operating system at the next layer, and then 3 apps on top of that. And then we have a diagram here, virtualized deployment. So this is, VMware invented, they didn't really invent this, but they got all the credit. And so then we have hardware, operating system, hypervisor. So the hypervisor, as we've been talking about yesterday, is the key to virtualization. You can either install a hypervisor, which VMware does, or you can use the hypervisor that comes on the system and the hardware these days, which is what WSL requires, which is why you have VMware and hypervisor. VMware, VirtualBox conflicts sometimes with WSL2 because they both provide a hypervisor and they can sometimes conflict. But then on top of that, you have a virtual machine, and the virtual machine has essentially its own virtualized hardware layer, and then it has operating system on top of that. A full operating system, by the way. It has a full, binary lane, so you can emulate devices and things that you can't do that in containers. So you can, you can pretend that you have a fake mouse, and you can do that, or you can virtualize anything in the hardware layer that could be virtualized. That's what's up with virtualization, and that's what we've been using for the last, decade or so. And then containerization has always been sort of a thing. I won't get into the background on that, but we've had something called Shroot in Linux since the 90s, which is essentially the basis of C groups and everything that came about to make you have containers. These are all technologies that were built on Linux. There were versions of them in BSD and Solaris as well, but the one that really took off was the Linux one, and it's based on something called C groups. And so this is containerized deployment. That means the difference between a virtual machine and a container is simply that the virtual machine does not share the same underlying operating system. In a nutshell, if you were asked what the difference between a container and a virtual machine, that's it in a test. If you were asked that in a test or an interview, that's the main reason. The difference is containers share the same base operating system. They share the same base operating system. Virtual machines, technically speaking, each have their own separate operating system and separate virtualized hardware devices. By the same token, containers share the same devices. All the containers share the same devices. right? Because there's a container runtime which runs on top of a single operating system. So so if somebody say true or false, a container has its own operating system, what would you say? A container has its own operating system. True or false? I worded it a little bit weird, right? A container does have its own operating system. So let me reword that so it's a little bit better. Both of them have their own operating system, right? The key is the word own, their own operating system. And in that case, it would be false, right? Because a container does not have its own operating system. It shares the operating system with the other. That means they all have the same kernel. Okay? That's really important. So I guess that's the one really big distinction. A virtual machine can have, you can have a Windows virtual machine and a Linux virtual machine and a Solaris virtual machine on the same computer. You cannot have a Windows container. First of all, Windows doesn't have containers in that sense. So you cannot do the same thing with containers. They share all the containers. This is the most distinguishing thing about a container versus a VM is that a container, every single container using that container engine shares exactly the same underlying Linux kernel. They all have the same kernel version. They might have different applications. They might have different directories. They might have different things that they've mounted to network connections and stuff like that. But every single one of the containers is using the same kernel, which is the main piece of the operating system. That is not true for a virtual machine. On a virtual machine, they all have their own separate kernels and operating systems, and those things run on top of a hypervisor, which is, honestly, it's like a really minimized version of it. This is all going on YouTube, yeah. This particular video, particularly. The other one is already there too. So, yeah, the whole co-learning stuff is going on YouTube. It's not going to have any structure, but I'm going on. So, traditional deployment area. Early on, organizations ran applications on physical servers. There was no way to define resource boundaries for applications on the physical server, and this caused resource allocation issues. I'm reading fast because you can do your own reading. For example, if multiple applications run on a physical server, there can be instances where one application would take up most of the resources. And as a result, the other applications would underperform. A solution to this would be to run each application on a different physical server. But that didn't scale as resources were underutilized. By the way, that was my job, was to do that back then. And it was expensive for organizations to have lots and lots of physical servers. So they came up and said, hey, let's take this. IBM actually invented all this shit. They invented it. They were doing it on mainframe like decades before VMware. So virtualization deployment area. As a solution, virtualization was introduced. It allows you to run multiple VMs on a single physical server. Server's CPU. Virtualization allows applications to be isolated between VMs and provides a layer of security as information on one application cannot be accessed by the other one. So basically, it takes all the resources on the computer and chops them up. This is why you have to have a multi-core system. You could not do virtualization really. Modern virtualization required computers with more than one core, because at least one, when you do a virtualization, a core, you can't have a virtual machine unless you can dedicate at least one core to it, which means you have to have a minimum of two. Most of the time it's 4 or 5 or 8. And we have systems at our place that have like 250 or more cores. In fact, I think the record, I was reading someplace, there's systems with over thousands and thousands of cores now, which is another reason you should learn Go, or some language that scales horizontally instead of laterally, vertically, because scaling these days is about spreading stuff across cores because the core processing has already been maxed out. This is why it's so important that you get technology that can communicate and deal with running multiple threads of execution. It's also the basis. That was the primary factor in the development of Go at Google, while they were using Borg and Kubernetes, which is why Docker, Kubernetes, and everything is written in Go, and it's why you should learn Go if this is your thing. So virtualization allows applications to be isolated between VMs and provides a layer of security. All right, so virtualization allows better resources to be allocated. The problem with virtualization is that once you allocate a core, you can't take it back. As long as that VM is running, you can't take that core back. Easily reduces the hardware costs and much more. With virtualization, you can present a set of physical resources at a cluster of disposable virtual machines. Each VM is a full machine with all its components, including its own operating system. And what are the virtual machine engines out there right now? Let's talk about them right now. So the leading virtual machine engines right now in the general consumer space are VMware, VMware Pro. They're the ones who champion all this up front. And the leading open source one is VirtualBox, which was made by a company that got bought by Oracle. And we're going to use VirtualBox. There are a number of other virtualization technologies for Linux, KVM, QEMU, and a bunch that are not as mainstream and certainly don't work on anything but Linux. Therefore, my recommendation going forward for myself and others is to learn VirtualBox because it works on Mac, Linux, Windows, and you know, without any differences. Container deployment arrow. So QEMU works on more than Linux. Have you tried it on Windows? Zen, yeah. QEMU is not a VM. What is QEMU? Is it KVM? Is the QEMU? QEMU works on Windows. I did not know that. I'm wondering if it's an emulator. Is it Zen? Am I confusing QEMU with Zen? Help me out. So, what's KVM? Okay, you know what? Honestly, I don't know the landscape of Linux virtualization because I don't ever use it. I probably should. Yeah, because there's KVM, there's another, I remember Zen from the day. I don't know how they're related. I honestly don't, and I probably should know. Your ARM Mac using QEMU. You run x86 OSs on your ARM Mac using QEMU, really? But that's an emulation. Does it use a hypervisor? Does it provide its own hypervisor? Do you know? I imagine it does. Okay, so this is something I'm missing in my learning. So with the introduction of the hypervisor, I knew about VirtualBox and VMware, but then because they were so popular, then the idea of embedding a hypervisor in the OS and at the hardware layer as well, and enabling it at the hardware layer became a thing. And I missed the boat when that happened. I don't understand specifically what a hypervisor is, so I'm gonna go research that. I can't tell you in one word. It's from my current understanding, it's kind of a hypervisor is kind of a sort of like a spans. It's a minimal super teeny tiny operating system that bridges the gap between the hardware and the other base level OSs that run on top of it, and so I can't, but I could not explain it to you if you asked me. And that's probably a really important thing to be able to explain as an infrastructure engineer. So what is a hypervisor? A hypervisor, also known as a virtual machine monitor or VMM, is software that creates, what was the name of the VMware one, by the way? I want to say it was ESXi. I think ESXi was the name of that. There's so many different pieces. Workstation Pro. I have Workstation Pro. I've worked on some VMware, so ESXi and vSphere, right? Yeah. Okay, that's right. Okay, so that's their hypervisor, right? Yeah, I actually wrote some code for that, some Perl code actually that integrated into that. We were like tracking vSphere stuff. JS Linux. What is this? Run Linux in your browser. Oh, right, I've heard of this. RISC x86. Huh. QEMU processor emulator for and of the different chipsets. Interesting. So it's a chipset emulator. So QEMU is a chipset emulator. And does it have a hypervisor? This is interesting. It sounds like QEMU is completely in its own atmosphere compared to these other offerings. Yeah, if it can emulate ARM and Spark, I wouldn't put it in the virtual machine space at all. Would you agree with that? Is that what you're trying to say, Jenny, early on? That it's not a VM? You're saying that it's not a VM. You're saying QEMU works for more than just Linux. It's not a VM. It's bigger than a VM, right? It's an emulator. Interesting. Okay. It's not a virtual machine engine. It may create the ability for you to run what seem like machines, and they might even be virtual, but strictly speaking, it doesn't fit the virtual machine engine definition. That's interesting. I think Xen and KVM do, though. I think that's the case. And this is all Linux. These are all Linux questions. Again, I don't have a lot of knowledge with the Linux virtual machine world because I've been using VirtualBox forever and VMware, so I don't have that. Let's go back to what a hypervisor is. I want to make sure I nail this. I want to be able to explain it to somebody, and I can't right now. So a hypervisor, also known as a virtual machine or VMM, is software that creates and I just know you have to have one to run a VM engine. That's all I know. So a hypervisor, also known as a virtual machine monitor or VMM, is software that creates and runs virtual machines. And we know that among them are ESXi and vsphere. Those are from VMware, but they're not the only one. They used to be the only one thing in town, and now I think they've changed. I want to say LFX. Did I get that right? LFX, I think, is a hypervisor. A hypervisor allows one host computer to support multiple guest VMs by virtually sharing its resources, such as memory processing. So the hypervisor is the layer that connects the actual physical hardware resources to their virtual equivalents, sounds like. Hypervisors make it possible to use more of a system's available resources and provide greater IT mobility, since the guest VMs are independent of the host hardware. This means they can be easily moved between different servers because multiple virtual machines can run off a single physical hypervisor. Hypervisor reduces blah, blah, blah. Now, my feeling is that when VMware came out, it was the first and only sort of consumer grade hypervisor, and I think it even predates the name hypervisor. And therefore, when you installed it, it installed its hypervisor to its own hypervisor to interact with the VMs. And this is why you have conflicts now between that and WSL2, because WSL2, they resolved them since then, but at least with VMware. But the reason is that VMware, the first product from VMware Workstation or whatever, provided a hypervisor along with the rest of the stuff that runs on top of the hypervisor. And so along comes WSL, which is a virtual machine in every sense, and it had its own hypervisor. And that hypervisor is one that's now being built into Windows. Windows is now having its own hypervisor built into it at some point, it sounds like, from what I'm reading. And that originally seriously conflicted. That's also why WSL1 had no conflict. WSL1 was an emulator, and what I'm hearing Jenny say, QEMU is an emulator, and that's why it will never have a conflict. Because it's not actually bridging over to the devices, it's emulating those devices, which is totally different. And it's not making an actual bridge. A hypervisor is making an actual bridge to the physical resources. And so WSL2 conflicts with VirtualBox and with VMware. They cannot run on the same machine. You have to have one or the other. If you install one, you have to uninstall the one before you can use the other. HAL, hardware abstraction layer between the real device and software base, loosely called hypervisor, HAL, at the time. Nice. And the name stuck, really. Really, that's where it came from, huh? Loosely called hypervisor. Hardware abstraction layer between the real device. So the hypervisor is not just a monitor. It provides the hardware abstraction layer that connects them, the hypervisor, right? So it's actually probably the more accurate term would be a HAL, a hardware abstraction layer. So that is the thing that turns your actual memory into virtual memory. so that the software can map it all and everything. That's the key piece that has to be there. Why it has to be activated. And so when you read about Minikube installation, you say you need a Hyper-V as your driver. That's what they're asking for. Cypheric says in the chat, yes, you can also modularize the vCPU, VRAM, and vDisk. Yes. All right. So hypervisors make it possible to use more of the system's available resources and provide greater IT mobility since the SVMs are independent of the host hardware. And that's the best thing about all of this. You can actually, this is really great for education, by the way, and for hacking. You can make a Windows VM on Linux, hack the crap out of it, which is required, by the way, to get the OSCE certification at DEF CON for offensive security. One of the best, most prestigious certifications. It's like by invite only, pretty much, and they only accept like 40 people a year, and you have to do it at DEF CON, and you have to have a machine that has 8 cores, and because you're gonna be crapping all over Windows to get it to break and writing your own malware. And so if you have a VM, you can write malware with a VM. You cannot write malware with a container. So if you're in the security space, if you're listening because you're a hacker, you should learn the hypervisor. In fact, if you really want to be blown fuck away, I'm supposedly not supposed to be swearing here, but watch Gamozo, Gamozo, if he ever streams. He doesn't stream much lately, but whenever he streams, he actually writes his own OSs in Rust. And it's the only reason that I've ever really been impressed by Rust, watching him do that. And he writes his own operating system, his own stuff like that, just so that he can break shit. And you can only do that with a VM, because the VM engine is the one that emulates as accurately as possible the actual devices and the operating systems and all that sort of thing. So if you want to find a bug in, like, I don't know, the mouse driver or something, you can't do that with a container, because the container doesn't allow you to attack it that way. The container is all running off the same kernel. So the container in every sense is really just kind of a safe way to run an application. That's really all it is. A group of applications that are all running together. Gamozo is he's in my host list, but Gamozo. Pretty sure that's it. Yeah. The crazy dude fuzzes OS on the fly. Absolutely. Yeah, it's amazing. It's freaking amazing. So he's actually really famous with Black Hat. Yeah, he's been pretty famous with Black Hat for a long time. And he kind of tolerates me. He and I both have a decided annoyance with Python as a language. We have a couple things in common, but some things that we definitely don't agree on. I have very healthy respect for the dude. He may hate me, I don't know, but it's just really, the guy's amazing. So, but he'll really, if you really want to see, Black Hat security, the guy finding 0 days and stuff using a VM, then that's that. So hopefully all of this conversation about VMs and containers is helping me to solidify my knowledge, but maybe you too. Maybe it's helping you get a handle on describing the difference to somebody and making a decision architecturally. If you're in the CTO space, these days you can have, peanut butter in your chocolate or chocolate in your peanut butter. You can run, there's a thing called KubeVM now. No, KubeVirt. There's a thing called KubeVirt now that will run a virtual machine inside of your Kubernetes cluster. It's like, as if it wasn't confusing enough, KubeVirt technology addresses the needs of development teams who have adopted and wanted to use Kubernetes but possess existing virtual machine-based workloads. So let's say you built up a whole bunch of work based on virtual machines because, that was the thing that came first. Can I be more specifically, blah, blah, blah. So you can actually run KubeVirt now, and it will, which is really interesting because if it's a virtual machine, it really leaves me wondering if it's doing emulation or if it's actually bridging it with a hypervisor. If it's doing it with a hypervisor, I have no idea how it's pulling that off, because it's got to have its own hypervisor built in or some shit. I mean, it's got to be amazing because obviously you can't talk to the individual devices on the node. That would be a serious fucking security violation to do that. So KubeVirt is a thing. You can run your VM, inside of there, or you can run the other way. Minikube, by the way, was originally designed to be a virtual machine, a single machine virtual machine that is running all of the little pieces that are required for Kubernetes combined to make Kubernetes work, and that's why we're using Minikube. Okay, so there are two types of hypervisors. Research is type 1, bare metal, and type 2, hosted. So obviously KubeVirt is hosted. And I didn't know there was type 1 and type 2 hypervisors. This is the first time I've ever heard about that. So that's nice to know. Type 1 hypervisor acts like a lightweight object or operating system, runs directly on the host hardware, while type 2 hypervisor runs as a software layer on the operating system, like other computer programs. The most commonly deployed type of hypervisor is the type 1 on bare metal, where virtualization software is installed directly on the hardware where the operating system is normally installed. Because bare metal hypervisors are isolated from the attack-prone operating system. Yes, they are extremely secure. In addition, they generally perform better and more efficiently than hosted hypervisors. For this reason, most enterprise companies choose bare metal hypervisors for data centers. While bare metal hypervisors run directly on computing hardware, hosted hypervisors run on top of the operating system of those machines. Although host hypervisors run within the OS, additionally, and different operating systems can be installed on top of the hypervisor. I have a feeling that this was the original VMware, and that's why it works. The downside of hosted hypervisors, latency is high, and bare metal hypervisors. This is true, and actually, I have a feeling WSL2 runs on top of the bare metal hypervisor enabled in the operating system, which is, in the hardware, which is why you have to turn it on in your BIOS. I'm almost positive that that's what it's doing. I wish I knew that for sure. It's called LParse. Yeah, in mainframe world. Yeah, LParse, logical partitions. Yep, I remember LParse. And that's what I'm saying. The mainframe people have been doing this forever. I remember a mainframe dude telling me, he's like, "You want to run Linux on mainframe?" Yeah. How many CPUs do you want? He was doing everything they're doing that Amazon got all the credit for. IBM was doing it forever ago. They invented partition file systems and everything way before anybody else. They're just not as sexy, so nobody noticed because they don't toot their horn the way they should. They toot their horn about the wrong shit. Actually, I worked there for years. Hardware acceleration technology can create and manage virtual resource. Hyper-V WSL2 uses the BIOS option for VM acceleration. Right, but so here's my question. If you activate a Hyper-V inside of your BIOS, is that Hyper-V running underneath the base OS? I want to say it is. If you activate it in the BIOS, it's not sitting on top of the BIOS at that point. It's not. It still is on top of the OS. So when you activate it, what you're saying is, you're saying the operating system must support type 1 hypervisor by enabling it in the BIOS. That's what I'm hearing you say. And that the base OS must activate and use those, BIOS level system calls and stuff. That's what I'm hearing you say. So that allows is that not it? Something different? So suffice it to say, OS BIOS options for support goes to the OS, and then that OS is okay. So that essentially the why do you care? Because if the BIOS enables it, that means that the OS can accelerate. Type 1 is going to be way faster. So that explains a lot to me. That's why my old MSI gaming Trident machine, it's kind of a lab machine with a big old CPU and not very good board. It does not have support. And it fucking is slow, but it can do it. If I install VMware or VirtualBox, it works. If I try to do WSL2, I can't, or Minikube, because those I don't know if WSL2 does, one doesn't, but they require OS enabled Hyper-V, and they require the type 1. So this is good because then I can actually say, when someone says, okay, it needs to have you need to have a hypervisor, I'm going to say type 1 or 2. And I can know right away. I have a feeling that modern Windows 10, I don't know, but I have a feeling that modern Windows 10 enables a type 1 bare metal Hyper-V sort of performance that was not there before. WSL1 is not a hypervisor. It doesn't use it at all. It uses an emulator. It's totally different. So that's interesting. Okay. What is the cloud hypervisor? A cloud computing becomes pervasive, blah, blah, blah. I don't know if I want to talk about this right now. Container versus hypervisor. Containers and hypervisors are both involved in making applications faster. We talked about this. Hypervisors allow an operating system to run independent from the underlying hardware, although through the use of virtual machines. Share virtual computing sources and memory. Can share multiple operating systems on top of one server. So you can run Windows on Linux and vice versa. You cannot do that with a container. You can't. I don't care how much they tell you you can. You cannot do that. There's been some really Frankenstein shit you can do. You can run something called Linux Windows 98 through the web, which actually I think uses WebAssembly, but it's not actually running it. It's running it in your web browser. On top of the standard. Allow applications to run containers. Allow applications to run independently of an operating system. Yeah, that's fine. Can run on any operating system. All they need is a container engine to run them. That's not completely true. I swear that's not. There are certain containers you cannot run them on the same operating system, because they have binaries in them that require a particular version of the operating system. I think that's a lie. I don't believe that at all. This is on VMware site, but still. Are extremely portable since it in a container and application has everything it needs to run. That I agree with. I'm going to call bullshit on that. Personally, I think that's not true. You cannot. Because I run into this. You cannot run. If you have binaries compiled for a particular version of an operating system and your container is from scratch and uses that compiled binary, it will only run on a specific kernel that supports that binary's architecture. So that's a lie. That's a lie. That's a lie based on people who don't understand containers who think you're just going to run a bunch of Python shit in there. That's totally different. If you're running binary applications there that require certain kernel levels and stuff, so that was a false statement. That VMware page is bullshit. All right, so let's keep going. So traditional deployment, we talked about that. Virtualized deployment as a solution, virtualization was introduced. It allows you to run multiple virtual machines on a single physical server CPU. Virtualization allows applications to be isolated between VMs and provides a level of security as the information of one application cannot be freely accessed by the other. Virtualization allows better utilization of resources in a physical server and allows better scalability because an application can be added or updated easily, reduces hardware, and much more. Let's talk about that. You can actually snapshot a virtual machine at the spot that it's at, which is crazy amazing for testing, fuzzing, hacking, and just overall backups. So you can take a VM and you can snapshot it, and then you can do all kinds of crazy shit to it, and then you can snap it back and then get back right to where you were. Just as if you had reinstalled a brand new machine and installed all of the stuff up to and performed all the actions up to that point. Snapshotting a virtual machine, I believe, is probably the single greatest underappreciated value of having a virtual machine in the first place. And a disclosure, I was actually asked to help community college set up virtualization for their classes. So you can set that up because you froze the RAM. Yeah, you freeze everything. You freeze the RAM, you freeze the whole exact state. And the other thing about a frozen virtual machine image is that you can transfer it, and don't get confused with container images, it's totally different. So DigitalOcean finally supports this. So you can take VMware, right? You can have like a Linux image, a Linux Ubuntu server image or whatever. You can get it all set up, and you can freeze the image, and you can push the image up to any hosting provider that takes images. So DigitalOcean, any of these places where you click a button and it spins up a machine, they're creating a virtual machine for you. And some of these places will accept an image as is. So if you have a BSD system you want to run, fine. If you have a Solaris system you want to run, fine. And people use this all the time with Linode to run BSD and stuff, because they want to, or even Windows server. You can take an image because it doesn't matter what the OS is, and you can, if the hosting provider allows for it, you can upload a computer image, a machine image, and you can just run that there, and you just copy it over, and it just runs. You just tie it up to its storage over there, which is kind of uncoupled from the thing. These virtual machine images, by the way, they never embed the storage, like the disk. They put all their storage in a single file. Usually. usually one big massive file that grows as you use it. And that file is the hard drive for a virtual machine. So you have the actual frozen memory of the virtual machine in a different file, and you have the storage of the disk. And by the way, that single file of disk can be shared later with another virtual machine with a completely different operating system. So you can go over to when you got on Windows and say, hey, I want to take, it's like having a USB drive, but have it all be in a file. So that level of virtualization is pretty fucking amazing. I really love it. I think it's great to have that ability to do that kind of thing. Cypheric says basically it's just a directory on a hypervisor disk with a virtual image and config files. Yep. So no different from temp stopping and copying archive the directory files to a temp area and then putting them back and restore. Yeah. There's many other ways to accomplish this, and God knows we did it in the 90s. We had to, right? With virtualization, you can present a set of physical resources as a cluster of disposable virtual machines. So this idea of being able to throw away the machine, they call it like ephemeral containers, or throw away the container and then just pick up where you left off and, attach some storage and you're all good to go. That is a really core concept of Kubernetes. I really want to focus on that, even though it kind of comes from the virtual machine space. That kind of carried over into containers in a big way. For example, you're never supposed to save anything into a container while it's running because it'll just be thrown away. So this idea of disposability, or ephemeral, it can go away. It's just changeable. That's big piece of this whole thing. It's also the reason that some people yell at me for making workspace containers, which they're ephemeral, because I just mount a separate home directory for them, and those files get loaded up into each one. Each VM is a full machine running all the components, including its own operating system, on top of virtualized hardware. That's a virtual machine. Container deployment era. So here comes containers. Containers are similar to VMs, but they have relaxed isolation properties to share the operating system. This is the key difference between a container and a VM. They share the operating system. All containers on a given machine share the same operating system. Now, it's possible, and Minikube does it, that you can share several containers in a different virtual machine. So on the same hardware, you can have a workstation running VirtualBox, and you can have Windows, and you can have Solaris, and you can have anything, and you could have a container engine in each of those that would run containers for that operating system. So if you wanted to play around with BSD or Solaris Spaces, which is their version of it, you could actually run Solaris on OpenSolaris on VirtualBox and run their container engine in that virtual machine. But you couldn't run, Solaris Spaces in obviously in Linux or some other virtual machine, virtual or real. So therefore, containers are considered lightweight, and boy are they. I mean, if you have a 2 gigabyte container, you'll get yelled at. I'm not kidding. I have my workspace my Linux workspace container is 2 gigabytes, and that's considered massive in the container world, because containers are really just applications on steroids. That's all they are. It's like, instead of just having one script or one program, it's like a bunch of scripts and programs and resources and network connections and stuff all bundled into one, and that's what goes into the container. That's what a container is. So honestly, the best way to think of a container is to think of it as an application. It's a single multi-component application that's all grouped together. That's a container. It has nothing. It gets confusing for people because what's up with this Ubuntu container? It's running Ubuntu. It's actually running the Ubuntu OS with all of its little pieces and stuff as a container, and it looks like a virtual machine, but it's absolutely not. But it can get really confusing. Now, I like to do that all the time because it's super duper fucking lightweight. It's really, really lightweight. So I can start up what has all of my tools and everything in it, even though it's not really an application. It's a collection of all the same utilities and everything I would use to get my job done. And that is all contained in one thing. But when I run it, it looks like I'm just starting up another machine with all my settings and my prompts and my fishes and everything. It's actually not a machine. It's a container that has all those applications in it. The layers of snapshots that you can execute. Yep. So So they are decoupled from the underlying infrastructure. They are portable across clouds and OS distributions. This is super important. So I still have questions about this OS distribution thing. No, I don't. Let's think about that word. They said OS distribution, right? So you can have an Arch and an Ubuntu distribution and even an Alpine distribution. And as long as they all have the same compatible Linux kernel they didn't say across architectures. They didn't say that, and that's super important. You cannot take a container. This is something I found out very relatively recently. You cannot take a container that has a bunch of compiled binaries in it for x86 and run it on an ARM container engine. Does not work. It doesn't work. And the reason I'm bringing this up is because I think it's going to become more and more of an issue now that we have ARM showing up in the enterprise and showing up on people's laptops like Mac and stuff. You cannot, and this is a big deal because we have more and more people are writing, they're creating containers on container images on Docker Hub, and they have to distinguish it now. They have to say, just like basically containers are package management, bottom line. And they have all the same problems and advantages of package management. You cannot create a container or a package for x86 that will also run on ARM. It's impossible. It's impossible. The physical architecture of the chips is different. So you can't do that. You can't cross. So I don't want anybody, when they read OS distributions, to read in, architectures, chip architectures. Containers are locked down to a specific architecture. Virtual machines are not. All right, so containers, you'd have, but that's different, right? You'd have to. Now we're not going to put emulators in here at all. Emulators are a totally different beast, and we're not going to talk about them because they're going to muddy the water between a virtual machine and a container. Yeah, because emulators at the end of the day are applications. Boom. Wine. Think of Wine, for example. Wine is not Windows. It's an emulation of Windows, right? Containers have become popular because they provide extra benefits such as agile application creation and deployment, increased use of efficiency. I think really, I want to come back to this architecture question because it's super fucking important. Okay, because if you're deploying a Kubernetes architecture to the enterprise, you have to decide what baseline architecture your nodes are going to have. And I'm talking about chip architecture. So you're going to say, I'm going to have 5,000, I'm going to have it's all x86 these days, right? But what we're starting to see, this is why this is a new thing. You're going to start, if you follow the blogs and stuff on this, since the M1, M4 chip or whatever, since all the ARM stuff is all in the news now, and the K3S and the micro Kubernetes is a big thing, you're going to start to read about this a lot. You're going to start to see a lot about this because we now, everybody's not just x86, right? So pretty much every enterprise Kubernetes distribution or lightweight or bigger HPC or whatever, they're all running x86, which means whether it's Red Hat or Arch or Ubuntu or SUSE or whatever they're doing in Azure or AWS's own thing, they're all x86 architecture. But what we're starting to see now, and this is why do you care? Because if you are going to make a Raspberry Pi, God, this is really interesting to me. I'm going to have to test this conclusion on my own. Somebody test this for me. Because a lot of people are making Raspberry Pi Kubernetes clusters, right? For testing. Do I need WSL and Windows host to create, for example, Ubuntu container? Absolutely not. It depends on what container engine you're using. And it depends on what WSL you're using, right? There's WSL1 and 2, they're totally different. So here's my question, and I want to test my own statement here. if you build a Raspberry Pi cluster, and people do all the time, that means you can only run, from what I understand, and I could be wrong on this, but I'm pretty sure I'm right on this. When you run a container, so let's say you make a Kubernetes cluster with just Raspberry Pis in it, right? Or you build in the Raspberry Pi, or you build emulated x86, yeah. So when you run a container, when you deploy images to your Raspberry Pi cluster, let's say you have a cluster that only has Raspberry Pi. There's another question. See, this is interesting because going forward, this is going to become way, way more important. So why I'm spending so much time on this, because we're starting to see ARM architecture is catching up with x86, and we're going to see clusters that are going to have nodes. We already have this situation with GPUs, right? And this is interesting because I just did a node feature deployment, node feature detection deployed to Kubernetes, so that when people schedule work, which is a container, to be run someplace, they have to say, look, I want a GPU that has this spec. And they're going to eventually want to say, I want this to run on a machine that has an ARM chip CPU. You'll be limited to ARM images. Yeah. Okay. Thank you for that clarification, because I'm almost 100% positive that was true. You could use labels, right? And yeah, there's a million ways to do it. Actually, node feature discovery, that's exactly what it does. It uses labels. It uses labels. It actually uses annotations. It's annotations because it's labels and annotations. So this, we haven't got into this yet, but one of the ways that you associate work that you want to run in Kubernetes on something is using this, what they call node affinity, which is like setting up the criteria for where can this thing run. And one of those things could be, does it have this label? And that label would be generated by an operator or something that has examined the host operating system and said, hey, you've got ARM here, or hey, you have GPU version whatever here, or hey, you have CUDA, or no, you don't have CUDA, or you have this sensor over here attached here. So you have to be able to, and the way that information about a specific node, a node is a computer in Kubernetes parlance, is a machine. The way that you communicate that to that information is through labels and annotations. Annotations predate labels, but they're both still there. So, yeah, and you pull this image for the specific platform. So the reason I got stuck on this particular point is because it's going to become even more confusing going forward. So can I run, so strictly speaking, if I make a container image for that will run on a Raspberry Pi, same exact application, maybe written in Go, right? If I make an application from scratch container image for Go, for that in Go, I have to compile that for ARM, and I make a container for ARM, a container image for ARM, and I publish that wherever, Docker Hub or GitHub. And then what? If I want that exact same application to be able to run on an x86 machine, I have to make a separate container image, just like I would have to make a separate package if I were making APT package or Pacman or something. I'd have to make a separate package. So if you're trying to get your head around what containers are in the sense of distribution and work related to them, my favorite thing that I've heard somebody else say is containers are just another package mechanism. That's what they are. But they're not just the packaging mechanism. They're also the way to run that package as if it were its own thing. And if you're wondering if this kind of architecture has influenced Snap and Flatpak and all these people that are coming up with these different container, package systems, it absolutely has. Because a lot of those things, NIM, you guys, what is it, NIM? I think NIM is the one. Is it NixOS? NixOS has got the same sort of idea. So there's been smart people along the way who have noticed the commonalities between these this containerization, these packages, and these basically runnable packages, we'll call them, right, with an entry point and everything. That's really what they are. They're runnable packages, and they've noticed how this containerization, how much overlap it has with package systems in general, APT, all those depackage and all. and they've taken advantage of that. And then this is why I'm so fascinated by, I think it's NixOS, because it has kind of leveraged this idea. And Geeks, by the way, Geeks is the GUI, whatever. It's taken a lot of lessons from this as well. So it's really been influencing so containerization has been influencing the whole package landscape in general. And this is also why you see companies like GitHub doing things like, oh, hey, we're going to host NPM packages, and hey, we're going to host all your container packages, because containers in a very real sense are the modern universal method for packaging. And so if you when you're creating, like, for example, I created links and I had a bunch of customizations that I wanted to put in there, right? And I had to choose, how do I distribute this? Well, I could have made it an APT or a Pacman or something like that and put it on the AUR or the DUR or whatever. I could have distributed it that way. But instead of doing that, I made it into a container. And now it can run anywhere there's a container engine. Anywhere. And it can be dockerd, it can be CRI-O, it can be whatever container engine is compliant with standard Open Container Initiative, which is now the... Honestly, and if you want to get really crazy with this, you can watch Jess Frazzle's Willy Wonka, or if you look at Rancher OS, the Rancher OS, the Rancher operating system, boots the kernel, and the very first thing it boots after that is the very first and only thing it runs is a container engine. It's super fascinating. Rancher OS. So Rancher OS, the first thing it does is start a container engine, and every single thing it runs from that point on, including systemd if you want, is encapsulated in a container image. Everything, and from initd to systemd, and it can all be swapped out and everything. So we're starting to see people like really seriously experiment with the idea of containers being the universal package distribution method. So as a developer, if you're listening to this right now and you're trying to decide how should I get my software out there, the first thing you should learn how to do is write a Docker file. If you don't know how to write a Docker file, you could learn how to write an RPM spec, which I did for IBM for years, or all these other things for packaging. But if you want to skip all of that, just learn how to make your application into a container. And that is the center of the DevOps movement. That is the basis of the entire DevOps movement. But subsystem containerization, like that's Cypheric's word, that is a thing, and it's going to become more of a thing. And it's going to be very interesting, because I think as technology advances, I'm going to say something that's very controversial, but I think we're going to start to see this kind of slow deprecation of our current existing package systems, including the ones that are used for Red Hat, Deb and RPM and Yum, and those are all systems. Those are not packages, D packages, stuff like that. We're going to start to see the centralization of package software distribution being done in containers more and more, particularly with K3OS. And you're starting to see these smaller scale Kubernetes distributions, but all of them are built on one finite atomic unit, and that unit is a container. So even down to the network card, I know. God, Taniwa was telling me about some stuff that's going on at the low-level hardware stuff that is all built on basics for containers. It's fucking amazing. In fact, I would go so far as to say, I could geek out on this all day. should probably stop. I would go so far as to say is that the future internet will be a bunch of containers. People are talking about like web assembly and all this shit. I'm like, no. What's coming is much, much, much bigger than that. The future internet will just be one fucking massive Kubernetes multi-cluster. That's what it's going to be, or something to that effect. Because it's already doing it. So all of this it's all going to be running off gRPC communication over MTSL. It's the modern next gen worldwide network is not going to have anything to do with HTTP. It might have a little bit, but it's going to be this. I swear to God, it's going to be this at scale. Because it's already touching, the containerization of the world has already touched everything. It's touched everything. It's touching like tiny minute devices. That's what K3S is, the tiny ones. So the Internet of Things people are already using Kubernetes to manage how they put their device drivers on their sensors and shit. So, people ask me all the time, like, what's the big deal? Why can't I just have a server? Because this is where it's going. This isn't, and it's this economy of scale and the yak shaving kind of thing. We're fixing, this is kind of massive at scale meta yak shaving. We are fixing a bunch of these little problems that enterprises are having in the process. For example, something as simple as containerization of our packages and our software and stuff. That little yak shave that we just did has like revolutionized how software gets distributed and run. And that's where Kubernetes comes in. We've talked about containerization as distribution method. We haven't talked about containerization as a way to distribute and load balance and all that other stuff. And that's what Kubernetes is. So containers have become popular because they provide, I'm reading from the script, the thing here, provide extra benefits such as agile application creation and deployment, increased use of efficiency in container image creation compared to VM image use, continuous deployment integration and deployment. That's a big thing. That's CD. If you ever hear the term CI/CD, continuous integration, continuous development, this. They usually have a symbol of the infinity, and it just means you're constantly putting software out and it's testing itself and doing it. It's kind of the happy hope that we can get to. It doesn't really work, but we're getting there. Reliable, frequent container image builds and updates. So rather than saying like me, right, you find a security problem and you're like, oh, I have to fix that. I have to download the package and update it and re-implement it and write a change ticket. No, continuous development and deployment is becoming, we're going to see more of this too, by the way. Amazon already has an Evergreen Linux, which automatically updates itself with security patches and stuff. And we're going to start to see this more and more. That's what Kubernetes does. So it's the really amazing thing about Kubernetes. I'm going to jump ahead here. One of the coolest fucking things about it, this is just so crazy. I can't even tell you how cool this is. So when you get a Kubernetes cluster actually running and working and stuff, the pods, the stuff that's all running inside your cluster is all, packaged into a pod. And those pods are built up of one or more images. And those images are hosted on your own private registry, right? So in order to deploy, let's say you make a change to one of your applications, you update the image and push it, and it gets automatically redeployed to the entire cluster without any additional work at all because of policies. So your cluster says, you set up a policy saying, get a new image if it's a new one. Always use the latest one, right? And that's the policy. That's declarative, right? That's what I want it to do. And then this is just so fucking cool. And you can watch it happen. You can watch it happen, right? So to a guy who was like responsible for security updates and everything like that, like for years, my job was like running down the latest version of this package and writing, auditing software to check on systems to see if they were at the latest level. You don't have to do any of that shit anymore. You don't have to do any of it. You put it in the cluster, and somebody wants a new change, any one of your customers, you don't even have to be involved as an operator. At that point, you're just the guy making sure they don't violate policy, which is what I've been doing all this week. All this stuff is pretty scary. You don't want developers just deploying without any checks, right? Because they'll use up all your resources and stuff. And so there's things called gateway policies you can set that'll say, you don't get in here unless you follow our policies. But they're all computerized. They're not something that you have to check, through some hand process. So as long as everything passes, you just update the image, or your developers update the image, and you can dynamically watch the image get redeployed in any number of load balanced ways by just pulling down the latest image. Boom, like that, directly. This is why enterprises are gaga over Kubernetes. They're absolutely fucking gaga over Kubernetes because this completely eliminates massive swaths of complications and expense within the enterprise, that in the traditional enterprise, where you would have to get a new server and deploy it and get the application approved. And if you're a developer, you'd had to bow down and, pray to the bastard operator from hell that you would put your application in there, the whole Dinesh versus Guilfoyle conflict from Silicon Valley. That's all gone now, right? As long as they're following your policy, you don't even have to talk about them. So to many, CTOs, Kubernetes is like the kumbaya moment between operations and development. And some people would argue that's what DevOps is, philosophically. It's like, I don't give a shit about your application. As long as it falls within these policies, doesn't use more than this much CPU, doesn't use more than this, I don't give a shit what it does. And so you make sure to put those policies in place. You don't have to talk to your developers. So if you are that operator who doesn't like to babysit developers all the time, Kubernetes is your friend, because you can put all this stuff and say, fine, just go deploy it. You just sit back, let them do their thing. And then somebody's going to break you. But here's the really great thing about Kubernetes. So if somebody breaks you, so if you have some wild cowboy developer who figures some way out to break your Kubernetes cluster or a single node or hoses up a node, which by the way doesn't hose everybody else up, you know why? Because if their stuff starts to not work, Kubernetes will say, uh-oh, and it will like reschedule all their work on some other system automatically. So that's, if you're using CRI-O, oh, I love CRI-O. I think CRI-O should be used everywhere as much as possible. Dockerd is the default still, but so that's like really awesome. I mean, think about that for a second. Not only does Kubernetes auto heal if somebody's application goes crazy, but you can like find that crazy ass application, and that is my job. My daily job, for the most part, is to monitor any applications developers or applications that go rogue and that somehow overcome our policies and end up hosing up a node or something. A lot of it's, making sure the nodes are healthy, which is still an area that has to be addressed because there's a separate operating system on there. And that's kind of the problem, right? You have this beautiful system for managing everything except for the machines that are hosting the Kubernetes nodes. And those things still have to be administered. Those nodes still have to be administered in using all of the old school infrastructure engineering and operations techniques, which means they have to have security patches and all this shit and everything. This is why K3OS and Rancher OS are so compelling, because they don't have any of that. They are also containers. So you're like, wait, we went to all this trouble to like distribute all these applications, get out of this system management shit, but you're telling me now that I can't actually manage the actual operating system that way? I want to do that. That's the next wave. The next wave of this whole cloud native thing is going to be Kubernetes integrated operating systems. And they're already starting to pop up. K3S is one. What's the other one? The one I mentioned, Ranch OS is trying to do this. KOS in order. Yeah. There's probably a couple more I haven't figured out yet, but that is really the holy grail. So that's like the one, I think the CoreOS people, I don't know who owns them now, but they're all working on that same sort of idea. Because once the OS is just another containerized application, then the entire fucking thing can be managed. And now we have, like somebody said yesterday, SATA for enterprise IT. Like you can swap in when you bring a machine online, all you're really doing is adding CPUs and memory and stuff. Hey, Vera is very, 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 very educated on this particular point. I'm glad he joined. He's really, really much more, and he's very pedantic in all the best ways. So this will be great to have him here. How much time have I got left? Okay, so we got an hour left to talk about this. In AWS, you can have Fargate nodes, and you don't need to manage the underlying VM of the node. Really? I hadn't heard about that before. The maintenance became to upgrade versions of the Kubernetes itself and test that still runs as expected. Yeah, that's the maintenance now, right? So we actually, just to give you a sense of how this works on my team, and if Vera can correct me, I work with Vera. Yeah, there it comes. So again, the statement, so this little conversation we're having right now, for those of you who are just joining, is about what's on the horizon. This is not part of certification or anything, but the containerization of applications and the orchestration of them with Kubernetes is a given for all the reasons we just discussed. The next wave seems to me to be the integration of the containerization and the virtualization and all those things with actual hardware machine management. Right now we have two teams. We have a team that takes care of all our infrastructure. And so this is a sore point for Vera. So let's, I'm going to give a hypothetical. Let's say Vera 01 here is, has an idea, or he's asked to deploy a development cluster, and he's, been given permission to, set up like a several nodes and stuff like that. He still has to go to the network people and to the people who make machines and put the machines in the raised floor and manage them. There still is that step where he has, get all of that stuff there before he can build the cluster on it. And by the way, when they build those computers, it's when they build out those computers, they also have to make sure all of the right versions of Kubernetes software are on there and everything. And yesterday we talked about the company that decided to go with Nomad instead of Kubernetes because of particularly that one single pain point. With Nomad is another orchestration framework that's not Kubernetes at all, but it does similar things, and it still is based on containers. And for a while there were several competing orchestration frameworks, Docker Swarm, and Kubernetes is really just level the playing field. I mean, completely. They're just, they're not even there really. But in this one case that I read in this blog, they went with Nomad because it had a single binary that had to be installed on any computer, and then it was a node under Nomad. Nomad is a separate HashiCorp alternative to Kubernetes that they've been pushing a lot, and there's really intelligent people. I'm super impressed with everything I ever see from HashiCorp. And Terraform had some quirks, but so far everything I've seen from them, and I'm not in a position nearly as well to establish whether they're good or not as somebody like Vera's got a lot of background in this, but that's just my initial impression. So now we're talking about, well, what's next? Is there going to be an operating system that is built in Kubernetes aware? Is Kubernetes going to come out with an official operating system that goes with a specific Kubernetes version? Those are all possibilities. Does anybody know of anybody doing that? To update to a specific OS, add a new one. It has to be approved by them. Yeah, Azure are top and very creative. They're pretty amazing. So we were talking about K3S. But see, I think Vera brings out the issue here. So when cloud native first came out, and you can, just a reminder, if you go to see the cloud native landscape, right? If you go to landscape.cncf.io, you get a sense of how many different technologies are related. And when you say cloud native, what's going on here. And thankfully, the landscape from 10 years ago has really kind of shaken out, one of them being Kubernetes. But right now, it seems like there is a lot of shakeup happening, and there's going to be some eventual winners, I think, in the operating system Kubernetes integration. That those two things are one. And right now, I don't see a clear leader. I haven't even heard of anything besides K3OS myself. I'm totally new to this, but Vera says there's many of them. So used to be involved in the Talos one. Is that how you say it? Direct SSH login to the server. It's just done. Right. Exactly. Talos systems. Ooh, that's cool. Let's look at this one. So Vera's posted a link to something called Talos, which says here is inherent control, infinite adaptability, Kubernetes lifecycle management, reimagined from the operating system to the entire stack. Here it says it's a minimal, immutable, it means it can't be changed, and ephemeral, that means it can come up and go away. OS ensures Talos provides a known secure base for Kubernetes. So this is the pain point in the Kubernetes IT space. So this is what CTOs stay up at night with right now, because they can manage the security of their Kubernetes cluster, which is a pain in the ass all by itself, but they still have to manage the security of the host machines on which Kubernetes runs, which means they've just added like an extra layer of security concern. And, Docker in the past has not been people don't get warm fuzzies when they think about security, because Docker traditionally ran as root. It doesn't anymore, but, and there's a million of, I understand from somebody in our chat reported that DEF CON this year, Black Hat this year, the keynote was about how to hack Kubernetes clusters and get access to the underlying nodes. And so this is a real thing, whether you're attacking or defending. And there was another big thing where some Russian hacker group they gave up some information in their attack, and they disclosed that they were using Kubernetes to run their attack as well as a tool. The known secure base for Kubernetes, Talos claims to be that. That is where it's going to be. It was going to be really, really good. Were you there, Vera? That's cool. Yeah. So no shell or SSH access reduces attack surface and enhances operational stability. So in other words, you can't hack the thing other than I would think, yeah, that's nice. Yeah, that's nice. I definitely need to go back and watch the whole thing. I haven't done it yet. I should probably do that on stream. That probably wouldn't get me banned. I wonder if we could do that. That might be fun. Yeah, I need to watch it. But all this cloud native stuff is like really bubbling up in the security space. And one of the huge there's two huge pain points in the security space. One of them, of course, is the dockerd running his root thing, and that caused podman to be created, a bunch of other stuff. And the second one is getting access to the nodes. So you still have to manage the security patches and stuff for the underlying nodes. Um, and that whole container D socket sort of runtime thing, which is going to be interesting. I think we should probably watch it together. I'll put it on the calendar for next week. Let's put that on the calendar for next week. I'll put that on my schedule. So you guys watch for the schedule on that. It's going to probably be between the 12 and 3 time slot on the weekend. I'm going to do between 12 and 3 on a weekend, my time. I'll definitely put that keynote on there. It's not a very long keynote, so we can put that on there, and I'll put that in the schedule because I really want to watch it. I would love to get the feedback from other people, hackers and otherwise on that. Yeah, basically you have an admin container in Docker that allows you to admin it. However, the OS itself is all wrong. So Vera, I'm just curious on Talos, what happens if you break out of the container runtime? Is there anything to break out into? Sounds like no, right? So the problem with the current systems is that if you can abuse the container runtime or the kubelet or any of the software used to run Kubernetes to make it into a node, that's what makes it. This defines it as a node, is it's running the software. You can, and it has a socket for the container engine. You can abuse those things to gain underlying access to the node underneath it. And it sounds to me from what you're explaining that from Talos, there's nothing underneath to gain access to. And that I think that's how RaptureOS is as well. Even though its subsystems are all running in containers, you could get access to those subsystems perhaps. So Vera says, I think they introduced it. It was in the talks before to have the logs are syslogd and from the host system to a container. Oh, right. I mean, there is a full OS there. There, however, is no way to download a file onto it. Right. There's no way to get the file. I mean, you could probably, yeah, I mean, the attack vector would probably still be, how do I fuck up the socket so I can get onto the underlying OS, right? Break myself out of shell of my own creation or something, right? I mean, it'd be a different kind of thing. The OS file system is read only. Oh my God, you gotta be kidding me, really? That is amazing. That is amazing. So even if that doesn't give you access to it, wow, that's so cool. See, so I mean, we kind of had a little segue here. I'm really glad Vera mentioned Telos. I'm going to go read about it. This is not going to be on any kind of certification exam or anything, but since we were talking about the architecture underlying containers and virtual machines and Kubernetes in general and the benefit of a containerized world and how that might actually take over the internet at some point, at least in terms of web applications, there's the web documents and there's web applications are kind of different. But it could very well take it over. And one of the serious pain points for security that would have to be overcome before any such amazing future would ever happen would be the OS needs to be integrated with the orchestration system, Kubernetes in this case. So and we're starting to see stuff like that with Talos, which is that sounds really amazing. I can't wait to read about that. Yeah, definitely adding a bookmark there. I'm going to leave that one there. So I'm going to take a break for 5 minutes and we'll come back and we'll do another 40 minutes of training and reading. And I'm going to try to continue reading through this and we're just going to work through it as we go. I didn't get to my Minikube installations, but I got Minikube on there. We did that yesterday. We got Minikube installed and we started playing around with it. And we talked about why we're picking the virtual machine engine that we did. And we're going to come back. Thanks for the pitch here, Anonymous. So I will be here. And I'm going to take a 5-minute break. We'll be right back. Let's get back at it. We got another 50 minutes before I go do my run. I'm gonna go I've been trying to do my run at the same time every day. I've been doing my run at like 3 o'clock or so. So this will be a video up on YouTube, just to let you know. I'll cover that again later, but lest anybody get afraid, I'm not going to be posting VODs to Twitch at all. It's just too hard to manage them in 2 places, so that's the place to go look on YouTube. All right, so we're going to go back to we're reading right now, trying to read through this background documentation. That's just a reminder. There's only 3 sources you can use for the certification exams for documentation. You can use Kubernetes Dot Io, blog.kubernetes Dot Io, and the Kubernetes source code on GitHub, and that's it. You can't use any other thing on the test. So we're using the resources that are available on the certification exam for that reason, and we're using web browsers, graphic web browsers set at the same resolution that I would use on the test, so that things are familiar. We concluded the last hour with a discussion about VMs versus containers. We kind of went down several, rabbit holes, good ones, about what may be coming in terms of OS integration with Kubernetes. And that doesn't immediately apply to certification, but I think it's important to keep sense of that. And then we're going to keep going. So on this bullet point here, Dev and Ops separation of concerns, create application. We're reading still the advantages of containers. So we talked about this document actually talks about the historical steps that led up to where we are. We started with traditional, servers and, putting software on them. Then we went to virtualization, where you had like a pretend machine that was running, and maybe 2 pretend machines running on the same actual machine, virtual machines. We talked at length about how things like QEMU and other emulators are not virtual machines. That was a point that I learned that I was unaware of. I didn't know the difference between QEMU and KVM or Zen, and I do now. Container deployments are where we're at now, and it's a container world now, and even the nature of the container itself has been standardized. So, and somebody asked me about CRI-O versus dockerd. And they're both really good. I don't know which one I would pick to deploy. It doesn't matter. You can have both container engines on nodes in your same space, and it's probably fun to jump ahead and say that on every Kubernetes node, which is a machine running Kubernetes as a worker or whatever, they have to have a single Docker engine. A single container engine, and by default, that engine is dockerd with Minikube, but it could be, there's a number of container engines. So when someone says Docker these days, they may not mean Docker. They mean a container engine that originated with the Docker engine, which was the first one to sort of commercialize, the idea of containers, which was, I don't want to get into the debate, but it goes back to, C groups and stuff from Linux, KVM. KVM converts Linux into a type 1 bare metal hypervisor. Oh, really? I didn't realize that. We just actually read about type 1 hypervisors and the difference between bare metal and software hypervisors. It's not a VPS? Oh, we'll say what's not a VPS? What did I say was not a VPS, Billy? Did I miss something? QEMU. QEMU, yeah, they were telling me it's an emulator. QEMU is an emulator that can run different architectures. And Jenny, is Jenny still here? Jenny was the one saying it. She was saying it's not. Her statement was it's not a virtual machine. It's an emulator, and then it runs on top of KVM, and that's why I was confused. I'm actually, your explanation of KVM really helps me understand it better, and her explanation of QEMU. She was telling me because she runs ARM software. She runs ARM stuff under a QEMU all the time, and I was like, well, isn't that a virtual machine? It's just a set of scripts for managing either KVM or Zen. Interesting. Okay, so is the statement QEMU is a virtual machine true or false? It's like cPanel would manage a server, right? So KVM and Zen are the providers of the hypervisor. Is that right? So QEMU does not provide a hypervisor. KVM and Zen are providing the hypervisor. And we talked at length about hypervisors earlier. if I read all about what they are, because I could never really articulate what it is. It's just a virtualization of the hardware devices. That's that Hypervisor is. That's it. And QEMU is just a set of scripts for managing all of that. Okay, so you can't call QEMU strictly speaking a VM or a VM engine. It's just a way to manage the VM engines, KVM or Zen, which are both virtual machine engines themselves. Is that true? True or false? KVM and Zen are Linux-based virtual machine engines. Sounds like yes, and they both provide a hypervisor. Okay. Does KVM only type 1 hypervisor, or does KVM provide a type 2 as well? And is Zen only type 1 or type 2? The type 1 is bare hardware, type 2 is software emulated hypervisors. So I'm just curious. With the same commands. Okay, got it. So I'll wait on that one. Both are type 1 only. So both Zen and KVM change Linux into having that OS and give it the ability to be a bare metal type 1 hypervisor, assuming the operating system, the BIOS, supports that, right? So you'd have to have a BIOS that supports it if you're going to do it from the OS. I feel like I understand that much better now. We went over that a lot last hour. All right, so let's read ahead. So we're continuing to read the list of advantages of containers. Both have to have hardware support, right? Whereas like VMware provided its own type 2 hypervisor without support early on, and that's what got me confused. So yeah, I mean, we can come back to that later, but that was the source of my confusion with regard to VMware. I was like, why does this work if I don't have BIOS enabled, hypervisor stuff support? And I was like, because it's using a type 2 hypervisor. Yeah. All right. So dev and ops separation of concerns are all type 2. Yeah. Virtualization. Yeah. VirtualBox, VMware, Hyper. So WSL2 is using, can use either one, but it will use type 1 if you use it. And that's why you get conflicts. If you have two type 2 hypervisors, you get conflict too. I think WSL2, I don't know. Do you happen to know? Is WSL2 using a type 2 or 1? Because you don't have to have it enabled. I think it's actually smart enough to detect it. 100% Hyper-V. Yeah, WSL1 uses emulation. So is that emulation include a type 2 hypervisor, or is it just emulating the Linux kernel? From what I understand, it's more of an application than it is a hypervisor at all. Yeah, WSL1 is kind of a funky, weird thing that will work, but it's strictly speaking, it's not even a Linux kernel. It's a Linux kernel emulation. I've heard the developers say that themselves in the Microsoft conference. So that's also why it gets around some of the problems that WSL2 has with hypervisor support and things like that. All right. So dev and ops separation of concern create but fixes for WSL2 running VMware Pro and also VirtualBox have all three running with their latest updates in parallel. Yes, there have been many. I've read about those. As long as you have the latest operating system and a computer that has a true hypervisor. I have one that does not, and it will not run both. So that's something to consider depending on how old your hardware and your operating system are, your Windows operating system. When WSL1 did a middleware that rewrote the Linux kernel calls. Yep. And I saw about that. It's really amazing that they did that. Yeah, they rewrote all the kernel calls. They emulated every single system call to the kernel. DevOps and ops separation of concerns. So we're going to return back to benefits of containers. Create application container images at build time rather than deployment time, thereby decoupling applications from infrastructure. Observability not only surfaces OS level information and metrics, but also application health and other signals. Observability is one of the big topics I keep reading about and hearing about in Kubernetes land. It feels like there's more space there to fill and to settle on. They realized how bad an idea was. I know. So they rewrote the WSL1 to be a hypervisor. Yeah, awesome. Environmental consistency across development, testing, and production runs the same on a laptop as it does in the cloud. That's the container. And this if you're a developer, this is the thing you care about right here. It works on my machine. that whole thing is gone, because what people are doing now is they're creating development images rather than having to force everybody to use some sort of web interface, which is sort of related to this. You can just set up a build environment that is consistent, and you can have everybody use that build environment, and it can just be the thing that builds it, or it can be an entire, sort of operating. It feels like an operating system that they can log into to build. I do this all the time to build C code. I don't want to put C libraries and stuff and have to use Arch or something that has the very latest libraries and, a huge AOR to go to. If I don't have the latest, I can just get, I can use Kona in the container, which is a C build container, pull that down, compile my C code, and just use the artifact that comes out of it, the executable. I don't have to do that. So that's modern development practice. Modern development practice is to create a container that has all the stuff you want consistently, so your whole team can use the same one, and then build out of that and take the stuff out of it and put that into your release or your artifacts. That's modern development practice. If you are not doing that today, you're doing development in a very archaic way. Honestly, if you're not doing it that way, and every time somebody makes an argument about using Arch because it's better for development, they don't know about this. Almost every time they suggest that, it's because they don't understand that. They don't understand the new normal for software development. So yeah, Cloud and OS distribution portability runs on Ubuntu, RITLS, CoreOS, blah blah blah. More advantages of containers: application-centric management. So we're focused on applications. Raises the level of abstraction from running an OS on a virtual hardware to running an application on an OS using logical resources. Another advantage: loosely coupled, distributed, elastic, liberated microservices. So microservices can be load balanced. They can be taken down and up all the time without impact. These are things that were really, really plaguing people before Kubernetes. Resource isolation, another advantage. Predictable application performance. Remember I said you can actually put policies in place that stop particular applications that are going to use more than a certain number of CPUs, CPU processing, or RAM or whatever. I'm actually dealing with constraints right now. I have to add the constraints to my specification for the thing I'm deploying. Otherwise, it won't pass our security policies, our not our policies, but our application policies. So resource isolation, auditing, and policy enforcement. That's another reason to use containers. You can't even do that without it. So and there were audits and things you used to be able to do. What are we talking about? Welcome for what? For the containerization things or the deploy chart thing? Yeah. Vera wrote a lot of our deploy chart stuff that's doing our policy protections and validation and stuff. So he's been instrumental in doing that, using as best as we can tell, policies that are best practices out there and putting those out there. And yeah, he actually did deploy all of our security policies. He pulled them out from wherever, collected them all up. And if you're in a company, this is something, if somebody else is doing this kind of thing, I'd be really interested to hear your insight into this. We have quite a few people here today. So if there's anyone else who wants to chime in on how they manage their security policies, it's not directly related to what we're reading right now, but I'm super interested in it because we have our way, right? We have our policies that we went out, that Billy mostly went out and got only. I don't know if anybody else even did it. He went out and got all of these policies that he decided were best practice and put them in our tool that actually sits on top of our Helm chart deployments to check out everything that we deploy to make sure that it passes our own policies that we want to hold ourselves to in terms of like resource utilization. Is it running as root? Those are basic ones, but there's many, many others. And where do you get them? Who decides what they're going to be? I found there's a couple of things online, and this is, if you guys want to talk about this more, we'll come back to another day. I might talk about it next Friday, but this is something that I'm going to be doing on a daily. I still have to do my Jupyter Hub policies. I'll get that finished this weekend, but what I'm trying to get at is how do other IT shops establish what their Kubernetes policies are going to be? And I realize that's like a quantum leap from reading about what containers and VMs are to specific sources for OPA gateway policies, which is like, there's so many steps before, that point that you have to understand before you get to that. But at the layman's terms, it's the stuff in Kubernetes, the add-on stuff in Kubernetes, which is semi-standard at this point, that decides what gets to run in your cluster and how, and that is super important for DevSecOps. For CKA certification, you have to know Rego and you have to know Gatekeeper. You have to know how to be able to produce these policies, not just go find them and why they're there and how to create them. So, but my question is specifically, what are other people doing? This is a pretty big question. I imagine not a lot of people are going to want to share, but I'm super interested. You wouldn't have to say your company, of course, but I'm just super interested to see how people manage that question internally. In their larger corporations in particular, do they have a team that's, associated with policy compliance? Yeah, it depends on three things, Farah. Vera's answering my question here about one, do you have a security department? If so, they do it. Oh, so you would have a security department that manages the policies in Kubernetes. That means they would have to know about Kubernetes. This is, continue with your points here. That's just one of many, three. But I just want to comment on that. So if you have a security department, one of the things that's really, really coming, I'll read these all again, Billy, in just a second. But one of the things that's really become clear to me in this whole Kubernetes adventure of mine is that your Kubernetes, it's not just like you have a cloud native infrastructure team. You have to have segments of expertise within your team that cross every IT boundary. And the security one is the one that reminded me of it that you just mentioned. So you can have a security team who has no idea what OPA Gatekeeper is. And because why? Because that's Kubernetes knowledge and skill, right? So what's happening now is that IT teams, this is why I'm so intent on sharing this stuff and helping you guys learn it. Because if you're going to enter enterprise IT these days, good chance you're going to be inside of a shop that's going to be doing Kubernetes stuff. And those people that are doing Kubernetes, you can't just be a network engineer. You have to be a network engineer who understands how Kubernetes does network routing. You can't just be a security person. You have to be a security person who understands OPA Gatekeeper policies. You can't just be a software developer. You have to be a software developer who understands Kubernetes pod deployments and how to set them up and write them. You see what I'm saying? So if the reason it's so important that you get this cloud native tilt to your skill set is because the enterprise expects you to interface with this one central bus. It's like the IT bus in terms of like skill sets, right? And the way it's going with enterprise cloud native deployments and stuff, if you can't interface into specifically the Kubernetes ecosystem with your skills, it's as good as you not even being there, because there's people, we had, I'm not going to get into it, but we had network problems, and a large percentage of the network problems were related to how Kubernetes does networking and how it's different and it affects the underlying machine and the ARP tables and all that stuff. And so the people that were trying to debug it were just using traditional old school server skills, and they were fantastic network engineers who had no idea how to do Kubernetes networking. And so what I'm trying to tell you is that if you're trying to break into the IT enterprise now, you need to add a cloud native tilt to your skill set. You can still stay a software developer, but you need to have that sort of skill set interface into the cloud native world. You need to learn how your skill set is going to start to migrate again. I'll refuse to listen to you. Yeah. So you need to add not just the baseline skills, but you need to add sort of a module to your skill set that plugs you into the cloud native stuff. It doesn't mean you have to be a full-blown fucking Kubernetes expert. It means you need to know your skill set as it relates to Kubernetes and cloud native. And that's what the CCAT is. It's also the reason I recommend people get this Kubernetes application developer certification first, because it clearly is skewed towards application developers. They don't learn how to set up nodes. The CCAT doesn't require you to set up nodes or anything, and machines and all that stuff. It's not an infrastructure certification. It's like, how do I take this software I wrote and make it integrate well into the Kubernetes landscape, the cloud native landscape? That means you have to know how to write a Helm chart. What the fuck is Helm? right? That means, you need to write a Golang template so you can make a Helm chart. What the fuck is Golang templates? You see, this is why I keep coming back to things like Go, even though you might be a Python developer, because if you don't know Go templates and you don't Go syntax and methods and stuff comes up constantly, because every application we've been talking about so far is written in Go. Every single application I've mentioned, except for the kernels at the operating system level, is written in Go. So if you're a software developer, you better damn well know it. And if you don't know it, you definitely have to learn Helm charts, and Helm charts are Golang templates. So I'm going to leave that point of rant for a second because I want to read back some of this that Vera said here. He's very, very fortunate to have him here. I'm going to, full disclosure, Vera was very instrumental, is the way he would put it. I'm going to say he got me my job, essentially, currently as an infrastructure engineer with no Kubernetes background whatsoever. And I've been, catching up on my own time, and with his help, a lot of his help on and offline here. So I really appreciate him coming here to help us. It depends on three things normally in terms of security profiles for OPA Gateway. We were talking about that. He says, 1, do you have a security department? And if so, they do it if they can, right? And that was the point I was making, kind of the side point. And number 2, do you use a security vendor? If they usually will define them for you. They'll define your policies and give them to you and put them in your cluster. Interesting. So if you wanted to work in the security space and you wanted to be cloud-centric security, that could be a place you could do that. That's interesting. It could be a way you could go about doing that. You could go into to the security space and do that, and you could still be in that, and then just have that. Anyway, so basically that's like capitalizing on not just the fact that you're a good security person, but I also know cloud and Kubernetes. Right. And as we said, that was the keynote at Black Hat this year, which we're going to show next week. Next week, we're going to watch the keynote to Black Hat. I hope I don't get blocked while I show it. I got to figure out a way to do that so that YouTube doesn't block me, but we'll figure it out. And number 3, Vera says here, who is the programmer that is always in the back wearing almost all black and has his headphones on all day? He's the one that gets to do it. Shut up. Is it permissive license? Yeah, I figured it would be. That's really hilarious, Vera. Yeah, I'm glad you put that in there. That's great. He's referring to himself. So there's always going to be that person on your team who's doing that sort of thing, right? But yeah, somebody's going to be thinking your policies. I absolutely know that. So the reason I brought this up is because when I started using the tool on the team, I wrote, built from the ground up. I'm going to flex here a little bit, but I built from the ground up all of the security auditing software for like this massive application at IBM that's running on 52,000 machines, doing security audit compliance on at least 50% of the Fortune 500. And so I wrote it. I wrote the protocols. I wrote the HTTP-based GPG dependent protocols for all of that, and most of it was all in Perl. And I absolutely know that there's going to be somebody who cares about security. By the way, none of my data ever landed on disk unencrypted. And I'm just going to put it out there. When they forced us to go on and use whatever the fuck it was called, Big Box or something like that. You know what the fuck is it? It had none of those considerations. It was made by a bunch of Mac people. My stuff blew it away. I'm just gonna say, okay, I'm done now. I'll move on. All right. So when I came to Vera's team, I'm like, what's up with these policies? Where do they come from? And how do we ensure they're being observed? And we actually had a conversation where it turned out only like 3 of them were even deployed in production, and they were all turned off at the moment. I was like, what the fuck? Why are we even doing this then? I'm having fun, Vera. Don't get upset. I'm not even pointing fingers at you. I'm pointing fingers elsewhere. So that's all I'm going to say about that. But I always, that flex was just to show that I actually do get to care about security. I kind of get caught off. I kind of get distracted easily by the security aspects of all of this stuff, because it's really complicated, and complexity breeds insecurity. There's like a ton of extra vectors to attack things when you add this much complexity, and it's one of my biggest concerns about the whole Kubernetes thing in general. In fact, I'm still rather cynical about it, about whether it can even be done securely at all. And one of the big pieces for being able to do it securely is the Talos kind of idea that Vera brought up with an integrated OS. And that'll go a long way to convincing me that this level of complexity in the infrastructure can actually be done by normal mortals and done securely by normal mortals. I strongly suspect it can't be, which is great if you're a hacker. If you're a hacker, just learn about it. Just walk over everybody, because there's so many vectors to attack. Like a month after they went into alpha testing, and most of our team can't tell what's going on with security anyways. Yeah, they absolutely can't. And I don't, that's not a slight. It's not their thing. I'm just saying I've been obsessed with security from the beginning. So immediately I'm always thinking, how do I hack this? And how do I prevent it from being hacked? It's built into me. I hope it's built into you. If you're listening to me right now, and you're in an IT capacity in operations or software development, I hope that you learn enough hacking to know, can this be hacked? You should be asking yourself that question every fucking day. You don't need a security title to be concerned with security. Is it a good idea for me to put this password in base 64 and store it on disk right here, and then commit it to source management publicly? Probably not a good idea. People don't ask this question all the time, and they get fucking owned. Most of the hacks that happen are like tiny little stupid superficial things that people forgot. And I'm just going to say it. Vera and I are hackers at heart and practice. We won't get into it. But professionally, it benefits you to think like a hacker, learn like a hacker, and think like a hacker constantly. Ask yourself, how could I break this shit? In fact, I really like this, because we're going to learn C. When we learn C, the module that I'm going to make on C is going to be learning C from a hacker perspective, how to break it. Not how to write it securely, how to write it insecurely and break the shit, so that you'll recognize the insecure C when you write it and when somebody else writes it. This is also the reason I don't like Rust, because it pretends to save you from that stuff, and that doesn't help you, because you don't know how to identify vulnerabilities, because some of them aren't there and some of them are there and you just don't see them because you don't think they're there, because they told you it's a nice, happy, safe language, instead of telling you, no, you should be paranoid and you should look at every fucking line of code and check to see if it's secure. All right, so it's also why you should run shell check, which I know Billy uses a lot. He's been using a lot if you're writing bash code. Somebody threw my Zet under the bus and said, no, I'd never write that in bash. Bash is insecure. And I was like, do they know about shell check? And they went, no. And shell check is the most amazing thing, because it makes you able to do things that you would be terrified of before, and you can do it with a relative degree of confidence, high confidence, because you know that somebody better than you is checking your shell code to make sure that it's safe. So let's keep going here. I have another half an hour or so, 20 minutes before I have to go. We're going to finish reading through these tutorials, and hopefully we'll get through the first one. We've already got Minikube installed with VirtualBox. If you have another driver, that's fine, but that's what we've got that we're going to work with right now. Why do you need Kubernetes, and what can it do? Containers are a good way to bundle and run your applications. In a production environment, you need to manage containers, what runs applications to ensure that there is no downtime. For example, if a container goes down, another one can start it up. Wouldn't it be easier if this behavior were handled by a system? That's what Kubernetes is. That's how Kubernetes comes to the rescue. Kubernetes provides you with all the framework to run distributed systems. It's going to be a while. It's going to be a while, but I really want to do it. It's going to be a while, yeah. But, stay tuned. It takes care of scaling and failover for your app. And now that I'm like working out and playing Dota, something called life balance, I understand. And going on dates with my wife again. Everything's getting delayed. God damn it. So it takes care of scaling and failover for your application, provides deployment patterns and more. For example, Kubernetes can easily manage a canary deployment for a system. You guys know what that is, right? You just deploy it to see if it's going to work. If it does, if it dies, you pull it back. It's basically a way of saying lazy deployments to large apps. We used to do this all the time. There was no word for it. Like if you're going to deploy an application to like 52,000 machines, there's no way to test that. You can test like certain bits of it, but you cannot test the load balancing and stuff at scale without significant resources availability. We didn't even have the resources. So a canary deployment is like one tiny little deployment on that scale that nobody knows about, and then kind of see what goes wrong and then add it up. The Chrome has a canary version. You probably know that's what they do. Because I mean, how can you possibly test deploying a web browser to every machine in the world? Kubernetes provides you with service discovery and load balancing. Kubernetes can expose a container using a DNS name or using an IP address. If traffic to container is high, Kubernetes is able to load balance and put that traffic over on a network so the deployment is stable. storage orchestration. This is a big one I missed when I started Kubernetes. My first question about the whole containerization of Kubernetes thing is, where does stuff get stored? Because I'm gonna share a flaw in my understanding as well. When I first learned about Kubernetes, like, I had virtualization on the brain, and we talked about virtualization. I had virtualization on the brain, so I was thinking in terms of, oh, is it going to have its own embedded storage as well? For some reason, I thought that it had taken care of through some magical way of redistributing all the storage as well. And it does sort of do that, but it's not nearly what you think. A container does not have storage in it. Anything you store in, if you're storing stuff in your container while it's running, a container is a running image. It's like running application with all the stuff. You know, if you have a directory or something you're saving in there, bad, right? Because that container is supposed to be taken offline and another one brought up without hurting anything. So then you're like, well, how do I save anything? You need to mount, other things into it, and those things kind of like having an external drive. If you want to visualize it, it's kind of like having a computer with a hard drive that's external. That's your /home if you know Linux, and then you put another operating system on there and you boot it up and you mount /home and you still have home again. It's all there. It's all still there. So, and that technique of mounting drives or even sockets or IP ports and exposing those or anything, that is fundamental to containers, but also to Kubernetes. Storage orchestration is what they call it. And when they were 20 years, when they were 20 years ago, that was fun trying to get your head wrapped around the storage thing. See, I can understand the PVC stuff. I mean, that stuff I understood. What I didn't understand is how it was being allocated, and I think that is a big piece of this. In fact, it's still a piece that I want to dive into more, because network attached storage is a totally different thing. It's related, but it's not the same as PVC. And so that's something I'm not there yet. Let's don't do that. Let's don't talk about it. Yeah, I know about PVCs and PVC claims. I know we're not there yet, but we'll talk about it. When we talk about PVCs and PVC claims and network attached storage and localized storage and allocation like that, I definitely want to do that. One thing, okay, so true or false? It says around storage orchestration. I just have one point that I'm going to ask you about, since it's on my mind. True or false? All of the, machine attached storage is pooled together in Kubernetes. I believe the answer to that is false. I think the answer to that is false. The PVCs and ES, very nice. Yes. Yeah. In other words, let's say, okay, let's put this in like really, really layman terms. Yeah, local disk. Local disk, from what I understand about Kubernetes right now, this is what I think I might have it wrong. Local disk is not available by default to Kubernetes. It is a part of the machine, and it is considered a part of the machine, and it is never added. So this, let me give you a really dumb noob way to think about this that I did going in. I don't want you to be me. So the first time I started to look at, I was trying to put all my Mac minis together with Linux on them. I know I have leftover ones. They run Linux great. Don't give me shit over it. I was going to put them all together, and I was like, ooh, this is great, because I'll have basically a SAN with like all the collected local disk drives from all my Mac minis. False. False. That is a false statement. If I put Kubernetes, I can put I'm kind of disappointed, actually. I was like, through some like magic that I couldn't even imagine at the time, I projected wrongly that all of these Mac minis with their 0.5 terabyte of storage were all going to combine and give me this big, massive network storage array that I was going to be able to use just because I ran Kubernetes. That is false. Right? So if you think you're going to take all your old computers and you're going to put them together and you're going to be able to pool together all of their storage resources that they have locally attached, you will be disappointed, because you can't do that. You cannot do that. The only way you can do that is through some other mechanism of making that local storage available to some other means, but it's not part of Kubernetes. It's not built into Kubernetes. Yeah, I was. Yes, it's exactly what I was. I mean, come on. People were raving about how awesome Kubernetes was, and it was, and okay, to be fair too, I actually applied for a cluster, a high performance cluster job in healthcare at IBM, where they put cards in every one of these computers, and they actually did join everything in a very real sense. It wasn't distributed like your job has to run with this many CPUs kind of thing. No, they actually combined the resources of all the CPUs and all the disk on all of those systems, right? So I was kind of, when I first came to Kubernetes and I heard Kubernetes cluster, I had the wrong impression of what cluster meant. I had come from the physical clusters that require hardware adaptation of the nodes. I mean, the machines, these hardware machines all had extra cards put in them so that they could actually team the CPUs. They were teaming CPUs and they were doing all kinds of amazing shit, and they were sharing storage to some degree. And so I had done a lot of research on that to get that job, and so when I came to Kubernetes, I had this false idea, and some of these beginners will not have this problem, but I had this false idea that it was an actual computing cluster. It's not. Kubernetes is not that type of computing cluster. That's not what it is. They call it a Kubernetes cluster, but it's not a true cluster in the high performance computing sense. It's not. It's a completely different term. So the term cluster confused the shit out of me. And that's what made me think crazy things like local storage was going to be pooled together in a massive, SAN array. No. So it's not that. All Kubernetes is a way to orchestrate work across multiple systems. That means if you have a job that needs 8 or 10 cores and you say you must have 8 or 10 cores to run, you're not going to be able to split that work across 8 or 10 computers that are connected CPU wise through a true original cluster. Because no, right? And you can, not an HPC cluster, right? And clusters as they are, right? So so I had actually had experience, not a lot, but I had actually had experience where if you wanted to run a job that was going to be split over multiple, had multiple threads, and was going to run over 10 CPUs, you could run it in these kinds of clusters. I never got to play with one. That's why I applied for the job. I wanted to. But you could actually run it on this thing, and it would split the work across those CPUs on different systems. That cannot be done with Kubernetes today. If you have a job that requires 10 CPUs to work for whatever reason, you have to have at least one machine, one node that has at least 10 CPUs, and that job, that work, whatever, is going to have to be scheduled and compete with any other jobs that have the same requirement on that specific machine, which is exactly why when I build my cluster, my local Kubernetes cluster, a big piece of my Kubernetes cluster is going to be a 64-core System 76 machine using like a Threadripper or some shit. Because I want at least one powerhouse multi-core system node in my local lab cluster to run high number of CPU, to at least test it, because otherwise the most I can get is like 4, right? Because all of my minis have got like 4 cores, that nothing has more than 8 cores, right? So I can't even test what a job would look like if it required 10 core CPU. So most part, however, most of the distributed work today doesn't need everything running on the same physical hardware, right? And that's actually very. I'm glad you brought that up, because that is absolutely what happened to the industry, right? I think the industry started realizing, and then CUDA happened, and then GPUs happened, and stuff like that, right? So a lot of other things came about, and it became more. And by the way, that not to mention the speed of the interconnect, right? The fiber and all the other stuff that sped up network stuff. And so all of that happened, and that allowed some of these like cluster attempts and things. They just kind of died and went by the wayside. I haven't heard about them at all anymore because it's all about microservices and gRPC over fiber and there's a million other ways now to accomplish the same. You just have to write your applications differently, and crypto comes to mind, right? So it's a really high performance thing. It can run, So if you write your applications differently, you don't need to do that. And it seems like the whole industry said no to the cluster direction that I was sort of interested in. I'm really glad I didn't take that job. I would be stuck maintaining some ancient hardware cluster that's not maintained anywhere. But yeah, it's also hitting the Bremerman's limit. I don't know what that is. Like Numa, I haven't heard about Bremerman's limit. Let's go look up that it is. Vera says here in the chat, the industry is also hitting the Bremerman's limit. I'm going to use graphics to search because reasons. Don't hold it against me. Oh, is that max speed of CPU? I didn't realize that was the Bremerman's limit. I thought that was the Moore's Law thing. That's a different thing, right? I must be mixing him up. Yeah. The heat of minimum size. Computation. Bremerman's limit. Okay. Interesting. Yeah, at some point they're going to hit that. Yeah, Moore's Law was about improving the efficiency of the chips over time, and the Bremerman's limit is a much more hard limit because it's based on the physics. I like this. Thank you for letting me know that. I did not know that. So that's interesting. Yeah, I'm definitely gonna add that to my list of things to bookmark. Hopefully you guys are getting some good tips out of that too to go read about. Yeah. So yeah, let's go to the next one. Once again, this is why I'm in science and technology. I'm just going to take a moment to make an advertisement for the science and technology category. God knows you've been hearing advertisements for the game and software development category. This is why I'm talking about science and technology right now. The Bremerman's limit has no fucking business in game and software development. So if you want to like tangent into stuff like this, I'm in the right category. I'm not yelling at anybody. I'm just telling you why. So let's see. Another advantage of containers: automatic rollouts and rollbacks. You can describe a desired state of your deployed containers using Kubernetes, and it can actually change the state to the controlled rate. So if it's doing too fast or too slow, you can turn it up or can turn it down. You can automate Kubernetes to create new containers for your deployment automatically, removing the old ones and adapt the resource to the new controller. I've done this. This is actually really fun to see. You just keep continually refreshing your, watch your get pods, and it's just so fun to watch. Automatic bin packing. Kubernetes allows you to provide with a cluster of nodes that it can use to run containerized tasks. You tell Kubernetes how much CPU and RAM you want, which, by the way, those resources are included in Kubernetes. So you can say, I want this much RAM and this much CPU. And those are settings you can set. You can say, I want this much disk, but it's a different process. I don't want to talk about it right now. Kubernetes can fit containers onto your nodes that make the best. We need to talk about, what you call it, CFS? About how to Vera, just remind me, don't let me forget. Later on, I want to talk about how to enable the local storage on my machines to be visible as network attached storage to, if possible, to the CEPH Ceph to my system. I mean, I know that you can have your jobs run on local storage if you insist on it, but I don't want to do that. I just want to see my options. It just bothers me that I'm like writing off all that storage capacity. That's always bothered me. Like, oh, hey, you made it into a node and now you don't have any storage at all. So CEPH Ceph is an open source software storage platform. Implements object storage on a single distributed computer cluster and provides three-in-one interfaces for object block and level. Yeah, that's exactly what I'm looking for. I've never played around with that at all. Looks like it's really fun to try. Thank you so very much for letting us know about that. That's definitely on my list of things to do. I think that is definitely valuable time for somebody who's building out their own system with a bunch of old machines that have, consumer grade, desktop computer hardware normally has really, big, spindle driven hard drives and stuff. And they're just sitting there and I don't want to waste them, right? I don't want to take them out and architect, some sort of actual physical collection of them together, but aggregation of them. But if there's technology that allows me, even if I have high latency, I don't give a shit, right? I would rather be able to use it for storage, be able to put like movies and videos or whatever, or logs or images or whatever. And it doesn't have to be really, really kick-ass, fast storage. I just don't want to write it off because I'm a hobbyist and I've only got so much money and I don't want to go buy a disk array. Now, I probably still will buy a disk array, but I also want to know what's possible for hobbyists out there so that they can leverage the locally attached storage, of their individual machines, which are becoming Kubernetes nodes. So you were told last week by a coworker that benchmarking new systems to get the max amount of transactions it can handle is a waste of time, that it is not done anywhere. I don't know what that means. Hopefully I didn't say that. I was told last week by a coworker that benchmarking new systems to get the max amount of transactions it can handle is a waste of time. Is not that. No, fuck no. We all do that. Any reasonable IT shop should be doing that. In my opinion, I'm with you on this one. I'm totally with you on that. That's why I ask. That's why I just asked. Okay, so let's bring this back to the ground for people who are listening who may want to make their own Kubernetes lab. Okay, or you're deploying Kubernetes for your company or your school or something, right? Benchmarking the hard rate drives into the IOPS. Yeah, it can do is complete waste of time. No. See. Okay, so this is where this comes in. Let me make it at a practical level, right? I have a bunch of old hardware that has lots of hard drives on them, and I want to put them in my cluster, and I don't want to waste all that great storage. It would be great to have it, right? If I put it up till today, I thought that. I mean, I told you before, I thought I was going to get Kubernetes was going to give me all that storage and make it into a nice, network attached storage array for me automatically. False, right? That doesn't happen. But today I just learned about some technology that allows me to put some sort of agent. It has nothing to do with Kubernetes. That'll allow me to sort of pool all of that otherwise wasted local storage by turning a machine into a local node, a Kubernetes node, into, a logical single thing that then can be mounted and used as if it were a network attached storage array, which might cost $5,000. Now, if you're a hobbyist, that's one approach. The question about performance of that, and I just said I don't care about the performance, right? Sometimes you might though. You might have a God knows we do at work. You might have an application that's meant to have certain responses at a certain time for disk IO, and you would not get nearly the same performance there as you would through locally attached storage or through even if fiber enabled expensive thing, which I'm also going to get. So let me paint a picture for you really quick about what I want to do eventually. I want to have a lab, and I want to put something like CEPH Ceph on there that allows me to use all the storage in a consistent way from any pod or any container I could ever write, can depend on that storage in one way or another, but it knows that storage is going to be slower. So I would never use that particular mounted drive or whatever network attached drive. I would never use it unless I was just doing really, really, high latency stuff. But other stuff that might have real low latency dependencies, like really dynamic logging or any of the streaming stuff I'm doing, right? So maybe sound processing, anything like that. I would want to have the fastest possible network attached storage array with the fastest possible networking, and I'm probably going to go fiber on all my stuff because I think I have fiber support by default. I think all my old computers still have fiber support, thank God. And so that would be some really kick-ass fast storage, but it would still be network attached storage. And then I also want to know what my options are with regard to PVC, which is Kubernetes' own internal way of managing storage, which I know almost nothing about now, other than that you have to say I want 20 megabytes as as a PVC is a physical volume, right? Persistent volume. Sorry, I want a persistent volume, and then you have to map a persistent volume claim to guarantee that one computer gets that all the time. And I don't know what the speed of PVC is at all, but I need to know about that, because those will be the 3 ways that I do storage in my lab, and then kind of emulate what I would do storage. At work we have GPFS for network attached storage, which gets us in trouble all the time because we're running certain things like Elasticsearch and stuff on it that can't respond to the indexes, don't work over network attached storage. So you have to, Vera actually is very, very ingeniously kind of, worked around that limitation and used locally attached storage on those nodes for that case, for those specific cases. But this consideration of where's stuff getting saved is a part of the architecture of a Kubernetes cluster, and it's not particularly. The simplest version of this is you have an S drive and you network attach an array and you're good to go, and everybody uses the same one, and then you just accept the latency associated with that, whatever that network attached storage is, that might be the simplest way, but it's not the way that will fulfill the needs of many, many, many applications. I mean, I can think of so many applications that have really, really high I/O, like storage requirements, and even if you offset that, with network connectivity, something has to write to disk at some point, and it's got to do it pretty damn fast. So how do you do that? Which thing do you make do that? No stuff. So the storage question is something that's going to come up later in our conversations. I'm not there yet. I'm over time. But we kind of got on it because we were reading that section about storage here, storage orchestration. We got Billy here talking to us about CEPH. So like coming back to CEPH, you sit here and think to yourself, I can do 20,000 IOPS to a local disk. Wow, really? If I go ahead and add 5 nodes and do across all of them, I will get either 100 IOPS or 20 IOPS, and then benchmark. It calls you smart and realize that you can only get 10,000. Oh, right. I see what you're saying. Thank you for that. So getting a new cluster, benchmarking the hard drives, get the IOPS. It can do is benchmarking the hard. You think benchmarking the hard drives is a waste of time? I don't think it is. Do you think it is? If you just had the system into production thinking, I have a lot of overhead room, and it turns out that it was not faster, it was much slower. Well, your entire production system was slower. Absolutely. Yeah, and I mean, obviously, Vera, I don't know what this person is saying or who it is, but I mean, obviously you can become overly pedantic on performance benchmarking ahead of time, but if you're going to be laying down a ton of cache on something and you're building out an architecture that's going to be running forever, and you're not going to want to patch all the time, that kind of benchmarking needs to be done proactively up front. I cannot overly emphasize my agreement with that. You're also talking to the guy who doesn't get shit done because I overly analyze what is necessary to get the task accomplished. And whether that applies to benchmarking disk or, just figuring out the structure of a particular algorithm, that would be me. I have to have everything in place before I do it. Sometimes I shoot from the hips. It depends on, I pick, my battles personally are with myself usually, and they're different. So when I'm trying to figure out what to do there, that gives me a lot of things to think about. One of the reasons I'm doing this stream, by the way, thank you so much for joining me. I'm wrapping up here. One of the reasons I'm doing these streams is because this rubber ducking that I'm doing with the community, with myself, and a bunch of people that know a lot more than me, is extremely, enlightening for me. I mean, this is how I learn, but it also just talking through it, even if everybody in here didn't have any more experience than I did, just talking through it actually really helps me to, it's just the way I process knowledge and data, I suppose, but that really helps me to get my head around this, because in the same sense of being able to explain something to someone, at some degree demonstrates more of a level of mastery than you would have if you were just doing it. So it's helpful to read through this and kind of, go off the rails and talk about it as we go. So I'm just going to wrap up this little section here and we'll move on. So Kubernetes allows automatic rollouts. We talked about that. Automatic bin packing. We already did that. Self-healing. So this is really cool. They actually have a game of Doom. Have you seen this? Anybody else seen this? There is a game of Doom, the first person shooter, one of the first, if not the first, that allows you to randomly shoot things, and it will destroy ports of your infrastructure to test your auto healing ability. It's an actual tool. People go around and shooting things, and if they end up breaking something in infrastructure that doesn't heal, then they know that they got to go look at that one piece and figure out what's going on with that thing. I really like that. I think that's kind of fun. So the most modern infrastructure these days is self-healing and redundant. This is kind of cool because I've been watching the season 4 of The Expanse, season 4 or 5. I think it's 5. And every time I watch them with the airlocks that just fix everything, I'm like, every one of those systems is gonna have like triple, quadruple redundancy because they could die at any moment. But there's so much redundancy built into and self-healing built into all the systems that they deal with every day that they just take it for granted. So the fact that Kubernetes is a self-healing sort of idea alone, that it's been built into this sort of codified and standardized, that's going to lead to, it's going to lead to this mindset where we want to make systems that are self-healing, that are, that self-correct and things like that. And then the more we do that, the more the systems become organic or similar to organic systems. So it'd be kind of interesting. Vera says, but if you just put that, oh, right, that's the same code. Secret and configuration management. So this is another big one. We're still struggling with this at work. Kubernetes lets you store and manage sensitive information such as passwords, time zone to stream description. No, but it's usually right here, Docker OID. I just happen to have web stuff up. Usually it's right here, my friend. I'm sorry, usually my terminal's up, and today it hasn't been. So everyone is struggling with that. Yeah, it's it seems like the security question, it relates to security, but how, Vault, it's hard to get into the problems and challenges of security and configuration management. We'll definitely deep dive on this particular point when we get to it. I may have some more personal experience with this. We're undergoing Vault deployment and some things. If people know this stuff, we're going to be going through some of that stuff. So I'll have more input on that. Vera actually told me recently that Vault installs a sidecar into everything, and with Istio that's 2 minimum sidecars and pretty much everything. At least anything that uses secrets. So and how do we when does something become a secret in Kubernetes versus a password in Vault? It's going to be interesting. Vault has nothing to do, by the way, with Kubernetes. It just happens to be something that can be used with Kubernetes. So, but this is, where does your secrets go? Where do you store them? And do you encrypt your etcd database that stores everything to disk or not? So this is something I was reading about some time ago, actually, from DevSecOps kind of reading. Your etcd is the application inside of the control plane of Kubernetes that stores all of this information. It's where it actually hits disk and gets stored. So all your configurations, all of the information about how your cluster is running, it's all stored in this really, really important part of the Kubernetes brain called etcd. And I think you can swap out the engines and use a different one, but that I understand is like the basic default one. And there's many ways to configure it. And by default, it does not store secrets encrypted on disk. It stores them in base 64. So, if you're a hacker and you want to break into something, that's nice to know. Because if you're able to break into one of the control plane nodes and get on etcd, not only because you use this centralized configuration management for all your secrets, not only do you get the password for that system, you get the passwords for every fucking system. It's like the holy grail of hacks. Seriously, if you can access, I'm speaking to the hackers and the security people right now. If you can access the etcd database in the control plane that stores the information for secrets, you have hit the fucking mother lode. That is the mother load. And the thing that freaks me out about this, as far as many options here, yeah. So how do you infer secrets to the app environment variables, volume storage, many options? Yeah, there's tons. And the way that you implement security in your application is going to be different. We're going to be talking about this when I do a lot of CKS preparation, because, how do you write an application that is secure, first of all? I'm going to start with one thing. Don't put your client secret tokens in GitHub. I'm going to start with that one. I don't care if your GitHub repo is private and only people from your company can see it. It's a bad fucking idea. Don't do it. That's all I'm going to say about that. I'm laughing because reasons. Anyway, we can talk about security later. I could go off on that all day. So what Kubernetes is not? Are we done with this? Oh, that's the last section. Let's read it real fast. So Kubernetes, do not limit the types of applications supported. Kubernetes aims to support lots of things. Okay, fine. Does not deploy source code. No. There's no source code whatsoever. You have to have a separate source code system. This is important. All right? Kubernetes doesn't come with a source code management system of any kind. You have to have one. It's pretty much GitHub, or GitLab. You need that. It's separate. Does not provide application level services such as middleware, message buses, data processing, databases, and stuff like that. There are a bunch of things that do, though, but does not dictate logging, monitoring, and solutions. Like that's for sure. You can do that however you want. So there's a lot of people that will, Elasticsearch is what people are using for this. Some have tried to use Splunk. Splunk is an older thing that's not built into Kubernetes aware. Elasticsearch is pretty much the leader there. We'll talk about that. Kubernetes doesn't provide it, but other providers do provide it. Does not provide nor mandate a configuration language system, for example, JSONnet. What the fuck? Provides a declarative API that might be targeted to arbitrary forms of code specification. This is a super hot button topic right now. And in fact, I just had a Twitter discussion sort of with someone. The declarative API, it's just a big REST API. There's a lot of discussion about this because it's kind of collapsing under its own weight of configuration complexity. And so people are suggesting that you should just rip out the configuration stuff and put in code, like, enable the people to write code instead of writing configurations, which is an age-old debate. It's like gulp versus grunt, if you know the JavaScript ecosystem. And there's a bunch of conversations on that front right now by really influential people in that space. So it's going to be fun to watch how that materializes. But strictly speaking, it's just a declarative API at the end. In fact, Kubernetes at the end of the day is just an API. The application that implemented that API and does everything to it is an implementation of Kubernetes even. Because almost any piece of it can be swapped out, almost. So that's the thing. Kubernetes does not provide nor adopt any comprehensive machine configuration, maintenance, management, or self-healing systems. Now, the key word here is machine. Okay, machine. Remember that whole thing I was just talking to you about? Ben, we talked about Talos and all that. This is a huge hot button topic too that people are racing to meet. When and if Kubernetes actually ever integrates with a specific operating system, and there's already some out there, this bullet point will have been addressed either by a vendor or by Kubernetes itself. But this has got to be addressed long term before Kubernetes really reaches the next level of where it's going. I have no doubt it will. But because why? Because configuration, maintenance, and self-healing. What they mean is nobody's taking care of your nodes. That's your own business. We don't do that. We don't make sure you have security patches on your machines. That's not our job. Your job is to put our endpoint on that machine and make sure the machine is ready to run that endpoint securely, and that you keep that endpoint, speaking of the machine, as up to this. I'm going to use the term machine or endpoint. An endpoint is just a machine. You put a node on there, the software to run Kubernetes as a node, and now it's a node, right? Well, they're saying they don't do that. That's not their job. And this is, if you're going to hack a system, that's one of the weak points. Because if you hack the system, if you can SSH into the machine that's running those, we do it all the time. It's actually kind of part of our team practice, which makes me uncomfortable every single time. But one of the practices is that you SSH directly into the machine, the host Linux machine running the Kubernetes node software, and you do whatever over there. Do whatever. You can use Docker directly, which people do. It's not a good idea, but you can. And the logs get hosed, or we've had this happen before. Logs on a node get too full on the local attached storage, and that causes the host OS to have problems. And then forget about running Kubernetes stuff running on there, because now the host is dead. So that's what this is all about. If you're going to infrastructure design, this is why I'm going to guess this is why people want infrastructure engineers and not Kubernetes engineers, because they want people who know how to fix the nodes when they go bad if they have to, and diagnose them as well. The reason I think that things like Talos and the integrated Kubernetes operating systems are going to actually take off is because there's a lot of money behind that idea. If they can make an operating system that is rock fucking solid to run Kubernetes, they will essentially eliminate the machine, configuration, maintenance, and manage people completely. You see what I'm saying? If a corporation comes in and they deploy an operating system that maybe is even on a box, right? It's like, who knows what Oxide's doing? Oxide might do that. Oxide Computing, they may actually end up offering that. But you go in and you buy a box that has Kubernetes pre-installed and an operating system that's read-only, that does one thing: run Kubernetes. That's it. That the cost justification for that to a CTO level executive is very, very compelling, because they not only are they going to be able to turn one key and get an OS and have that OS auto heal, basically it's not a firmware flash, but basically, you either reinstall the OS, which includes a node for the Kubernetes at a particular level, or that includes the whole OS. So instead of upgrading all the little individual pieces that might be insecure, you now have a read-only operating system running a Kubernetes node that's bound to 1.21 and can do its own upgrades to its own software and stuff, blah, blah, blah. It doesn't have any attack vectors at all. But more importantly, it eliminates the need for support. So people don't have to maintain, you don't have to ask people to install servers and nodes and then put Kubernetes and do it properly. These people who don't have any Kubernetes experience, that's all CKA stuff, by the way. So the CKA versus CKAD, that's all covered under CKA, how to set up a node, how to install kubeadmin and make it a kubelet and all that. So, and I don't know any of that. I need to learn it. So that's all there. But at some point, somebody's going to make a lot of money selling those boxes to enterprise. And if I were in the startup world right now, I'm not, but if I were in the startup world and I had any kind of hardware enterprise experience, that I would be chasing that shit with the fastest. I regularly give people startup ideas on this stream. And there's another one. If you manage to sell a rack mounted, multiple CPU node, the problem with it is how many nodes, how many CPUs you put in it, right? Some hardware vendor is going to figure this out. Some hardware vendor is going to figure this out, and they're going to make a killing. Some hardware vendor is going to figure out how to plug and play CPU modules to add a certain amount of CPUs per rack space mounted computer. And you'll be able to plug in the RAM, plug in the CPUs, and take them up, and then plug in the GPUs. And they're it's gonna be basically Kubernetes centric hardware. And when they start to make that and they make their own OS that includes Kubernetes integration, they're gonna make trillions. I imagine Oxide Computing has actually really got their mind on this. Makes me sad I can't do it. I wish I could. Dude, I'm telling you, it's obviously all these, none of these, none of these companies that have money will do it for new projects. They won't be doing it for old stuff. A lot of them though, then you have to sell them on-prem, right? But even if you don't sell them on-prem, you could sell them to the providers. You had HopSwap. I'm saying, man. Victor, go make it, man. If somebody becomes a billionaire off this, just let me know. I'm telling you, the companies, that's the shit they want right now. That's the sort of thing they want. Because, and then here's what you do. You would sell it. You would either sell that hardware to Google if they don't make it, or whoever the cloud providers are. You sell them that hardware. You sell them to the biggest cloud providers. Now you have like the best possible modular hardware. You're basically making elastic hardware to go with their elastic offerings, so that you can say, hey, we have a real high demand for, 10 CPU jobs for CHCL or whatever. And then you talk to, you know who's going to make it? NVIDIA's going to make it. Mark my words. I'm going to predict right now. What day is it? September. It's September 11th. Holy shit. Moment of silence for September 11th. I'm going to predict at 3:20 on September 11th, that NVIDIA is going to make a modular, hot swappable hardware offering that is directly compatible with Kubernetes at some point. Watch. It's either going to be them or Google. Nobody else has it in them to do it. Intel's too fucking slow. They're not going to do it. Yep. All right, it's going to happen. It's going to happen, and somebody's going to make crazy gobs of money. And the only company that I even, dude, can you imagine? Dude, if they buy, I'm telling you, I thought they already bought ARM, actually. I thought they already bought ARM, and I was like, I've been predicting that they're going to come out with their own computer anytime. But the thing with NVIDIA is they already know modular stuff. They had hot swappable CPU and network supported it back in the day. Yeah, way back in the day, right? I'm happy working for remote and not going to any CPD to close any hardware. Yeah. So, I think NVIDIA is going to be the one. If they get ARM, they're definitely going to be the one, because ARM is just a no-brainer to put multiple ARMs on a single chip and make them hot swappable. So you put like 12, 16 ARM chips on a single module, and then you plug and play them. Do you know what I'm saying? And then you plug and play them. I mean, the thing with hardware and plug and play hardware, we learned this with Socket 7. Anybody remember that? I'm really dating myself. I should not even bring it up. You guys are just going to laugh. Does anybody remember Socket 7? I built a computer with Socket 7 in it for all the reasons that they sold me on back then. Socket 7 was a method for plugging in a CPU modularly independent of your board. And the lesson learned from Socket 7, which failed miserably, was that usually when people are upgrading hardware, they have other things like the bus and stuff that are in the way for speed, and they need to upgrade those things at the same time. So the idea of pluggable hardware is kind of tilts toward the dubious side. Because usually when you're upgrading hardware, you're not just upgrading CPU, but this is why ARM is going to be really interesting, because ARM has got such different requirements that it might happen. And when you had to care about IRQs, exactly, Victor, it's exactly what I'm talking about. That was when I learned all about IRQs, and I bought myself a post board so I could see what was going on when my system wouldn't boot. You remember those days? I'm seriously dating myself right now. I'm sorry about that. Dude, you had to buy a post board. The kids don't know this. Yeah, you had it back then, so they don't even know what an IRQ is. So it's this is supposed to be Kubernetes. We could talk hardware another day. I don't even, did they even have, I mean, the whole IRQ system could have been totally reinvented. I would not know. I would not know, because I haven't been keeping up on hardware stuff and hardware innovation. But yeah, that's the way it was. Your stuff didn't work. You had to figure out what the conflicting IRQ was. This is back when you had CPU on a daughter board and the same disks and the MCI cards before their time. Yeah. Yep. They were on their own card and everything. Yeah, totally different hardware. I mean, this does kind of make me want to get into hardware and start building again. But when you're starting to, the only reason I brought it up is because at least in the 90s and early 2000s, the whole hardware industry was like, fuck no. Modular hardware is a bad idea. Okay, modular RAM maybe, you know, but the idea of modular CPUs, they're like, no, fuck no. But I think ARM could really revolutionize that. And I think if NVIDIA got a hold of it, which NVIDIA has been capitalizing on modularized hardware this whole entire time. NVIDIA is the only modular, you know, computer peripheral offerer, you know, company that actually directly changed the architecture of the boards themselves and PCIe and all that. Because everybody's like, oh no, we need faster stuff to deal with these new kick-ass GPUs that are coming out. And so they were actually influencing all the hardware on the board as well. You know, they were like causing changes to those PCI specifications and everything. And so now that if NVIDIA gets a control of ARM, they know how to play the influence modular. They already know how to play the modular hardware game. They've already been doing it, right? They don't do mainframe. They don't do motherboards and shit. But all they need to do is pull in like an MSI or somebody like that and say, okay, you do the motherboards, and we're gonna buy you now because we buy everybody. That's what we do. We're NVIDIA. What's that? $30 billion? Yeah, no problem. We'll buy you. We're gonna buy MSI straight up. You watch. So, you know, ARM, we bought you, and they're gonna buy them all up, and then they're gonna release modular CPU with sort of pseudo-elastic hardware. And as soon as they do that, they'll be providing all the hardware for all of the cloud providers and anyone else who wants to build on-prem, and they will rule the fucking universe. I keep telling people this, buy NVIDIA stock. You might hate the company. I don't care. I don't have any stock anywhere in any of these companies at all. I don't have enough money to have stock, period. But if I did, oh my God, it's kind of writing kind of on the wall. All right, end of session here. I'm going to go ahead and close this session. I'm actually going to close the stream. I will leave my stream off for a while. When I come back, I'll be here. I don't know what I'll be doing. I might be playing Dota or whatever. You'll see the notification. I'm going to do this because I want this particular session to be recorded and available on YouTube, which will be almost immediately under the live upload section. So that's where you can go see it. It will be stored on YouTube, and I will be putting these two streams on YouTube. They automatically save when I do this, so that's why I changed it and restarted the stream. These kinds of scheduled streams are the kinds that are going to do this. And just a reminder to everyone, if you go to rdbx.tv and then at the end of the Twitch whatever URL add /schedule, you can go see my current schedule. Tomorrow I'll be doing another one of these Kubernetes learning streams for my own personal benefit primarily, but if you want to join in, it's really helpful, between 12 and 1. And I'm going to be doing them. I have them scheduled every weekend and on the Friday, Saturday, and Sunday for a while because I want to get really certified and really up to speed on the Kubernetes stuff. So I've kind of lit the fire under my own ass on this. And but I might end up playing Dota for the rest of the night because it's a beautiful day and nice day. Who knows? I don't know. I did a lot of writing on the boost this morning, so it just depends on what I feel like. I'm going to go running right now. You go outside. Go enjoy your weekend. Thank you for joining me here. And on that note, I think I'm going to leave. Bye.